Hello, everyone, and a very warm welcome to the Filecoin Orbit main stage hosted by Protocol Labs and friends. Today, you'll hear from key stakeholders from across the Web3 ecosystem. But first, let's take a quick look back at some of the things happening across the globe this week as part of Filecoin Orbit. Community members from across the world came together to celebrate the one-year anniversary of Filecoin mainnet launch. From Nigeria to Portugal, we deep dived into the protocol, explored the potential of the network, and shared our stories. Let's dive into the stats. By the end of the week, there will have been 34 events across 12 countries and 5 continents, with 18,000 attendees so far. And what fun we've been having, from technical workshops in Germany to community dinners in Amsterdam and a hot pot night in China to a virtual job fair and presentation. There is still much more to come. To learn more and register for all the upcoming events, check out orbit.filecoin.io. A huge thank you to all of you. Now it gives me great pleasure to hand over to the man who's going to open the show today. It is the founder or the creator of Filecoin and the CEO of Protocol Labs, Juan Bennett.
Thank you so much, Angie.
Great to see you, Juan. What a great week.
It's been really fantastic to attend all these amazing events all over the world. All right, share my screen. Let me know if you can see that.
Looking good.
All right, great. Great to be here with everybody. Really excited to participate in Filecoin Orbit. This whole week has been just an amazing celebration. Happy 1 year. Happy anniversary to the Filecoin network. It's just been phenomenal to celebrate with all of the different groups around the world, from storage providers to clients using the network to developers building developer tooling. It's just been such a great week. And it's been so full of many different kinds of things going on, many different meetups. And I'm super excited for the lineup today. It's just going to be a jam-packed day full of amazing talks covering all kinds of things across the stack, going deep into protocol details of the protocol to high-level conversations about Web3 and where everything is headed. So stay tuned. Go to the there's a tremendous amount of things going on today, and yet tomorrow there's another full day. So it's going to be a super exciting time. So I'm going to give a quick overview of Filecoin and go into many of the achievements that we've been doing this year and just give a just general update of what we've been up to. As many of you know, Filecoin is a crypto-powered storage network. It is the storage network of Web3, and the mission of Filecoin is to create a decentralized, efficient, and robust foundation for humanity's information. It is a decentralized storage network that brings together storage providers from around the planet to safeguard humanity's information by using cryptographic incentives to organize the work involved in creating a cloud storage network. So you can take the data that powers your applications and spread it around the world, storing it in many different kind of storage providers in many different countries, and bring a Web3 verifiable cloud for the future. As one of the major things that has been going on this year is building out the retrieval provider side of the network. There's many different kinds of systems that need to come online to be able to have a kind of CDN level quality. So that's been a lot of ongoing work this year. And Filecoin is a huge protocol. There's a lot of things going on. There's the blockchain layer. There's the broader protocol network and the entire Filecoin improvement proposal process to be able to improve the stack. There's a two-sided market of storage providers and clients. There's a whole application platform developing on top of it. All of this is organized by a decentralized economy. There's a broader ecosystem of many participants, and all of this adds up to creating an open service that you can rely on, where all of the technology, all of the components are open source, freely licensed for everybody to use in anything they want, and where you can count on and count on the network without having to trust in a particular singular party in development. Filecoin is a big part of the next wave of Web3. We're looking at an environment with lots of different kinds of networks evolving, many new next generation chains, advancing the state of the art in what you can do with smart contracts and Web3 applications. We're increasing the transactional throughput, and Filecoin brings exabytes of storage to provide to all of these networks to be able to store application data, to be able to store data sets, and then be able to compute over them. It is a staggering, we've amassed a staggering amount of storage capacity. So 12 exabytes is just a humongous amount of storage capacity. And this is provided by over 3,000 storage providers around the world, which is just amazing to be in such a massive network 1 year in. And the craziest thing about this is that the growth rate is pretty high, and so I can't wait to see what happens over the next few years. There are hundreds of organizations building on the network, hundreds of projects in development, and thousands of developers contributing to all parts of the stack and building applications. So here's a view into storage providers. Like, this is the growth rate of the storage capacity in the network, and it's coming online all over the world. And last year, a year ago, I sort of posed 3 challenges for the network. Challenge 1 was to bring deeply valuable data to the network. That's happened in spades. I'll go into a few of the things that people have been bringing online. I asked everyone to build new applications on Filecoin Tech, and boy, have I been super surprised. Like, there's been hundreds of new applications, and many of those have turned into organizations and startups and so on. Many of them growing. And it's just been creating a super vibrant ecosystem. You'll hear a lot more about it today. And the third challenge was to make Filecoin yours, to really step up and make this network your network, to voice your opinion, to direct the protocol where you want it to go, to participate in all of the different parts of the governance of the community, everything from giving feedback to different things, contributing, filing PRs, making new applications, forming core dev teams, creating implementations, and so on. And this, I am super proud of everything that you have done in this whole year, and I can't wait to see what happens in the next year. So I'm going to give a quick overview of some of the clients that are using Filecoin now, and sort of the scale that we're seeing. So when we started the network, we had about 600 petabytes of capacity, and a little bit of usage, but not a ton. And this year, we've seen just this tremendous growth in the amount of usage of the data in the network. So we're now about to cross 30 petabytes of of deal data. So this is data storage that people are using to back up in Filecoin, and we're also getting to close to 1 petabyte of Filecoin Plus data. So this is the whole Filecoin Plus program is enabling extremely cheap storage for lots of people around the world, and it's really awesome to see that seems to be growing exponentially. We'll see if it keeps it up, but that's just like a really great to see. And this is coming from many different organizations using many different development on ramps. So one of the big contributions this year has been the development of these on ramps that enable all of this data to come online. Things like NFT.storage, many different developer tools and developer platforms, things like new applications like Estuary that help coordinate the client and storage provider process. Applications like chain-safe files, which give you a nice Dropbox-like experience to be able to store your personal files. Space.storage, that plus collaboration with teams. Video networks, where you can do kind of Web3 oriented transcoding of video and then backing it up to Filecoin. Things like Huddle, where you can have Web3 native meetings and then record it and back up to FFS and Filecoin. There's a whole application stack evolving, and all of that is accelerated by the cross-chain bridges that are emerging. So there's lots of connectivity from Filecoin to all of these other chains. And this is just a sampling. There's many other bridges either already online or in development now. So it's really great to see all of the connectivity from Filecoin to these other networks. One of the coolest things that I've seen happen this year is like this entire builder funnel that is now enabling many new organizations and startups to develop and form around the protocol. So everything from the beginning developer resources that builders need to know how to use the stack, to then opportunities to be able to create new projects through hackathons, to then a whole path to help them develop those ideas and projects into businesses or other kinds of organizations through grants and accelerators, and all that leading into ecosystem investors or grant makers that can help them succeed. And we've had constant hackathons this year, and it's just been I sort of was a challenge of the beginning of the year to just have a hackathon going at all times, and we have fulfilled that in spades. We now have many hackathons going on at the same time. It's just fantastic to see everything that people are building around the world, and so many of these are turning into other into new projects and startups and so on. Really great to see also accelerators helping support those projects in building. Here's some examples of some of the startups that have developed that started either as hackathon projects or went through accelerators and so on. So really, really proud of the entire builder funnel. So one quick shout out of how you can get involved. Hey, become a client, store your data on Filecoin, either your personal files or the files of your application by implementing by using one of the developer on-ramps. Become a storage provider. There's a lot of guides on how to go do that around the network. Build a new project, app or startup around the network. We have lots of tooling and systems and programs to help support you. Join the community. Come and chat with us in Filecoin Slack. Participate in the protocol development. So propose improvements, comment on other improvements, make your voice heard, and then potentially help implement that directly into a Filecoin implementation by joining one of the core development teams or starting a new implementation. And there's all kinds of tooling that is emerging to help gather the community feedback to know where we're headed. And also participate in events, either virtually or in person once circumstances change and so on. It's been really amazing to see everybody and to participate in a bunch of different events around the year. And maybe the last plug would be to join one of the amazing teams that's building in the network. Pretty much everybody that I know is hiring. Many teams are looking for amazing builders to join them and help develop their applications. So if you want to get involved, like one of the best ways to do that is to just go and join one of these teams. Everybody is looking for more awesome builders to help them out. So again, happy 1 year. Really excited to celebrate with you. This entire week has been truly phenomenal. Super proud of everything we've achieved. And this is just year one. I can't wait to see where we are next year, and then 5 years after that, and 10 years after that. So stay tuned for the amazing lineup today. And that's it. Thank you so much. And now over to Bailey.
Thank you so much, Juan. Really excited to hear all that Filecoin has done over the last year. And like you said, only in the last 1 year of mainnet. So that's really great. Hey, everyone out there who's tuning into Filecoin Orbit, the virtual summit that's happening over the next 2 days. I'm Bailey Reitzel. I'm a longtime crypto journalist and researcher, and myself with my colleagues are going to be your MCs over the course of this summit over the next 2 days. So after this next keynote, just a little housekeeping. After the next keynote, the agenda is going to break off into 2 separate tracks. In keeping with the space theme, there's the boosters track where you'll hear talks and panel discussions about the innovations happening within the Filecoin ecosystem today. And then there's the exit velocity track, and that'll cover the implementations and updates to the core protocol. So it's a really techie one, and I'll be your MC over there. But first, let's get into this keynote. I'm thrilled to introduce our first keynote speaker, Brewster Kahle. Mr. Kahle has spent his entire career intent on a singular focus, providing universal access to all knowledge. And he's done that by building, for one, the Internet Archive, which since 1996 has been archiving all the digital space, much of which would have disappeared a long time ago if it wasn't for this project. So that's why I'm so excited to hear him speak today. I'll go ahead and pass it over to Brewster Kahle, but please feel free to drop questions into the Hope and Chat, because at the end, we're going to save a few minutes for the audience questions. So yeah, Brewster, over to you.
Thank you, Bailey, and thank you to the Filecoin community. Happy birthday! I mean, look at this. This is completely great. You've pulled something amazing off here. A new type of storage system, and one that has got incentives built in to try to make it really last. Today also happens to be the 25th anniversary of the Internet Archive. We'll be celebrating that all day today here in San Francisco. And so this is actually kind of auspicious, I would say. What I thought I could do is try to give a bit of perspective of what Filecoin can mean within sort of an Internet Archive, or some of the issues that we've seen over the last 25 years in the building of Internet tools and technologies, and how that's gone right and wrong. This also is the first year that the Internet Archive has started uploading parts of the web archive into Filecoin, using Estuary and trying out the tools and really making it go, and it's working, which I think is just completely great. Universal access to all knowledge has been a dream for millennia. Right? From the Library of Alexandria on forward. The idea that if you're curious enough to want to know something, that you can find that information from the published record. That's the promise of, say, even the printing press, or probably more directly, Andrew Carnegie with his public libraries, which fueled so much citizenship and democracy in the building of the United States. The internet was the opportunity to make this dream really come true of universal access to all knowledge. What we have is an opportunity that comes in only maybe once a millennium. The opportunity that comes with a change of how knowledge is recorded and shared. There was going from oral traditions to manuscripts, from manuscripts to printing, and now we're in the middle of a transition from printing to digital. I was lucky enough to be in 1980, be there, and thought, what a fantastic opportunity to influence this transition. When there's a new transition coming along, it's a great time to be there. And you guys are right in the middle of another one. Of course, we are building on the vision that came before us. The dream of having a next generation publishing system had been around for a long time. Vannevar Bush's 1945 article, As We May Think. If you haven't read that, do. It still has really interesting insights into some of the telepathy systems that are starting to be developed now. It is a paper that keeps giving, even though it was written in 1945. Ted Nelson's Xanadu in the world of hypertext was very much in our minds at that time, and Doug Engelbart's way of annotating and enabling people to build on the works of others. The key thing turned out to not be the computers. It turned out that it was the networks, that was the important part of all of this. How can we communicate with each other? Yeah, anybody could go and write word processing documents. That's good. That's good. But could we make everyone a publisher? Could we make it so people could find their voice, have something to offer and share, and find their community no matter where they were in the world? Could you write in such a way that you could build on the works of others? By 1996, actually, we had that. It's a World Wide Web, right? It was pretty great. And by 1996, after we had kind of cobbled together and gotten that World Wide Web launched and running, we could then build the library. It was time to build the library. In 1996, I thought, why don't we just build this thing? I mean, how hard could it be? Sure, we're going to have to digitize a whole library, but how hard could it be? So a bunch of us set off to actually do it. And we started by archiving the most ephemeral of media, the World Wide Web's pages. We wanted to make it permanent because people were going and posting things, but they were disappearing. The World Wide Web didn't have a structure for longevity of the information written to it. This was a bug of the World Wide Web. And frankly, it's something that you all are helping trying to solve with this next step. So the library, I would say, is really kind of on its way. Right? 25 years ago, I set out to try to build a digital library. Now we're on, and yeah, we've got 5 million books in the open with a whole lending system. We've got 600 billion web pages stored, television archives, But there are still a few things that haunt me, things that aren't done well enough, things we need new and different solutions to. One is one that's probably not a really technical solution thing, but I think it's really coming up to being a problem. One is that information is starting to become more and more licensed, not sold. Back in the old days, you used to buy books, but the big publishers now aren't even selling ebooks. They're licensing them, and they're licensing them in such a way that they can pull them out and pull them away and change them at any time. This is really not a good idea for anybody other than maybe a few wannabe monopolist large-scale publishers. It's really, we need a game with many winners so that you can have lots of publishers going and selling lots of products to lots of people, to libraries, to having lots of bookstores. How do you have intermediaries when everything is licensed? Like bookstores and libraries. But bookstores and libraries are really useful and important for the future. Not just exactly libraries as is, but the whole idea of taking these materials that may have been published for one reason, but then you want to look at it from different perspectives. This is what libraries and people have done with libraries all the time. Other things that are haunting us, misinformation. Right? We have actual purposeful, wrong things being published and pushed on the internet to go and disturb the information ecosystem. It's spam of the World Wide Web and these social networks. We do not have the tools for going and dealing with these. In fact, some of the business models actually do well based on more and more misinformation, and so they emphasize it. This is bad news. So we need better tools for misinformation. We also need better tools to make sense of it all by stepping back and being able to see the big picture. These are some of the things that are haunting me. But hanging over all of us, the Library of Alexandria is probably best known for, well, burning, right? So how do we make this all last? Burning the Books, which is a book by the Oxford's head of the Bodleian Library, Richard Overton, points out that burning libraries is actually a strategic goal of regime change, say in Poland, in Serbia, and sometimes casualties of war, like a lot of the works in the Baghdad library when the United States invaded last decade. So how do we make things last? The Internet Archive started with tapes, then we went to discs, then we went to multiple discs, multiple copies in multiple places. We're starting to move to multiple copies and multiple different legislative structures. So this is a new way. But the D-Web, the decentralized web, I think is a much better way to go. And the Filecoin is an amazing step forward in this and necessary technology for making a decentralized web work, Web 3.0. How do you go and have websites live everywhere and nowhere? And in some sense, it's kind of a throwback to how libraries used to work. Publishers would put out a book, they'd sell a bunch of copies, they'd go to lots of libraries. Even if one of those libraries blew up, destroyed, left, whatever, there'd be other copies in other places. That's not the case in the current World Wide Web. That centralization is a real problem that we can fix, and Filecoin and storage and some of the other technologies are maybe one ways to be able to do this. Lastly, another thing that is a problem is when the Internet Archive has been archiving web pages, it really just archives what web pages look like. It doesn't archive working websites. So it's not as good as the original website in the archive. Can we go and archive living websites? The answer is yes, but we're gonna have to restructure the web. It'd have to be more like a GitHub, if you will, so we can fork a website, a working website. So having a website that has code and data in it in multiple places and be able to go and have that be updated over time, but then also be able to fork it. And that was the concept of the decentralized web. We've tried some experiments in this area. So the Internet Archive made dweb.archive.org. If you go there now, actually it kind of works. And you can go and see web pages and sort of a simplified form of the Internet Archive site that uses IPFS, WebTorrent, Gun, these decentralized tech. For the geeks out there, go and open your JavaScript console when you first go to dweb.archive.org. It is just a spectacular explosion in JavaScript as it starts to do the decentralized retrieval of parts that are the worldwide, that website. So that's been going along well. And now we're taking some of the last crawl of the United States government's websites, the end of term crawl, and uploading it into Filecoin. And that's been going along well. So what's the goal? We want a web that's fun, that's dynamic, that's private, that makes it possible for people to make money by publishing on the net, that have no central points of control, which goes and makes it so that we have some real bottlenecks and problems and centralization. So can we build this? Yes. Is it being built? Yes. Is Filecoin part of that? Absolutely. So how do we go and build all the rest of the pieces so that we can go and have, say, a WordPress site that lives everywhere and nowhere? A lot of people are working on some social networks things to be able to try to do that. I use it as a puzzle, just blank but decentralized. Can we make Slack but decentralized? Can we make Google Docs but decentralized? How about a Tesla? Right now, all that information goes back to central. Can we make Tesla but decentralized? So as just a sort of interesting tech puzzle is take your favorite tool and try to think, what would it mean to make a decentralized version of this? So just wanted to say thank you and happy birthday to Filecoin and the community for building something that's at exabyte scales already, that's completely great and being so open and inviting. The answer is protocols, not platforms, and you're doing it. Thank you very much.
Thank you so much, Brewster. I have a couple questions, actually, since we have a few more minutes. Thanks so much for your talk. You were talking about, well, there was several things that you touched on, right? We want the internet to be fun. And I think the internet right now, it sometimes is fun, right? And sometimes it's not very fun. But you were also talking about these better tools for managing misinformation and better tools for making sense of all the content. So as a journalist and a content creator, this is just something I think about constantly. All this information on the internet, all competing for readers and users. And so almost daily, I go through an existential crisis about whether I should even be putting more content into that space, right? And so I guess my question is, with all of this information, what is the reason that all of it should get saved? Or should there be some sort of metric for like what gets saved and what doesn't? I know that's probably an impossible metric to even create, but yeah, talk to us about that.
Well, the privacy is the flip side of universal access to all knowledge. Not everything deserves to live forever, but you actually don't know ahead of time. So in this, I know that there's sort of anathema towards the word trust in these in some of these communities, but I think we're going to need to go and have some organizations go and preemptively collect things and then not necessarily make all of it available. So the Internet Archive and the World Wide Web gets requests to have things not be, made available. That's so I think that's in the small, right? When you have sort of web pages that are embarrassing. But your bigger question was really actually, Bailey, a little scary, right? Should a smart person like you, a journalist, not even participate by going and making things available? Well, that is a scary future. We need to make it so that creative, interesting people are diving in, contributing, engaging, adding their stuff in, trusting the network. So how do we do that? I think by making it so that you're better off, not worse off for participating. By making it so that if you go and make things available, that other people will use it with some context, right? Could go and point to your thing and go and use it. But I think we went from pages to feeds, right? When did we do that? And isn't feed kind of an awful word? It's kind of like, horses going, putting their faces in troughs. I mean, is that really what the internet has become? I would like to go back to more contemplative, permanent pages that you can refer to over time so that when you, Bailey, do a good article, somebody can refer to it in the past. It doesn't just having scrolled past some endless headline and trash on some feed that is not referenceable. So I think having good URLs, and Filecoin has those, is absolutely critical towards having a medium that's going to be worthy of being more than just shoot 'em up games.
Yeah, that's fair. We will talk more about this at some point because I would love to pick your brain about some of this. And sorry about my cynicism there, where I'm like, I don't even want to publish. Thank you so much again. It has been such a pleasure to talk with you. And I'm sure everybody who's tuning in loved that talk as well. So again, thanks so much. We are headed into a short break where you all can find yourselves and the track that you want to be at. Again, there's the boosters track, which is ecosystem talks. And then there's the exit velocity track, which I will be your MC on in just a minute, which is about the core protocol. So stay right here if you want that. Otherwise, go to your next track and you'll hear from us very soon. And we're back. Do you know where you are? This is Filecoin Orbit, a 2-day virtual conference celebrating 1 year of Filecoin on mainnet. I'm Bailey Reitzel, a crypto journalist and all-around content person, and I'm your MC for this boosters track, which is getting into the nitty-gritty tech of Filecoin. First up, we have Molly McKinley, head of project and engineering at Protocol Labs, and she's going to give us a rundown of the development work that's taken place on the protocol this past year. So Molly, go ahead and take it away.
Hello, everyone. I'm so excited to be chatting with you today about all that Filecoin has achieved in year one. Just 1 year ago, the Filecoin mainnet went live, and it's been absolutely staggering to reflect on how much we've achieved just in the past year. We've built one of the largest data storage networks on the planet. We built the fastest upgrading blockchain, more than 10xing available chain bandwidth just within the first 8 months of launch. We built the cheapest large-scale storage network in the world, and we made it dramatically easier to add data to Filecoin and started onboarding large-scale users. Starting from the top, I'd love to count down the 10 most amazing improvements that we shipped to Filecoin in the past year to reflect on what Filecoin was then and what it is now. Starting at the beginning, chain capacity and storage capacity. It's been absolutely crazy to see what Filecoin has done in the past year in this area. When we started out with mainnet, we just had 0.6 exabytes of capacity across a little over 300 storage providers, and the network was growing as fast as it possibly could as new storage providers added data to the network. We had just a single implementation securing mainnet and had just accepted our first FIP into the network. In the early days, making new storage deals was relatively difficult. While it might have been cheap, you had to run significant infrastructure and tooling in order to kind of participate in the Filecoin network. It was difficult to select which storage provider was going to be best for you and your data. And finally, the application platform of Filecoin was really just getting started. We had a ton of amazing kind of users and applications coming from the IPFS ecosystem into Filecoin. We just graduated the first 100 projects from the Filecoin Ignite hackathons. And the first set of deals was getting made on the network, which was really amazing to see, but we've come so far since then. So starting with network storage capacity, we 20x'd the network storage capacity in the past year, starting at the very beginning with mainnet and now reaching over 12 exabytes of storage capacity. It's just absolutely insane to reflect on. And you can absolutely see how improvements like the hyperdrive upgrade accelerated the daily addition of new storage capacity into the network. And the number of storage providers around the world that came online, we added over 3,000 storage providers, which is huge. Thank you all for joining this network and community. It's so exciting to see what you're doing here. And just really strengthened and grew the whole network from a storage capacity perspective. This is just a tiny sample of all of the amazing businesses and companies and organizations who have joined Filecoin and are making it stronger by providing storage space. Looking at chain bandwidth, it's absolutely crazy to see the improvements launched here. I think we might be the fastest network that's ever launched such a chain bandwidth increase. The hyperdrive upgrade back in the end of June really accelerated the ability for storage providers to add new capacity to the Filecoin network. This helped the network double its onboarding rate kind of pretty much overnight, which is phenomenal. And it also brought a number of improvements around making it cheaper to make new deals on the network, making it easier for miners to reason about their infrastructure, and just in general, really, really leveled up Filecoin's game just within the first 8 months. So you can see the base fee became low, predictable. This brought some massive improvements with SnarkPack, which was kind of fundamental new research on how to, Filecoin being the snarkiest network out there in the world, to do that really, really efficiently. And now there's thousands of proofs being done every day. 7.4 million POREPs per day. So Filecoin is just absolutely scaled, I think more than any of us could possibly have imagined, which is really phenomenal. Looking at network security, it's been amazing to see 2 of the Filecoin additional implementations, Venus and Forest, join Filecoin mainnet, adding a lot more security to the network, helping kind of implement new Filecoin improvement proposals to the network, and in general, making sure that all of the Filecoin core consensus data is, fully secure across all of these different implementations. And two things that really help there. One, test vectors, which help us look between each of those Filecoin implementations and validate that the implementations are all saying the same thing and staying in sync. And there was also a major improvement to Lotus that launched, I think, in the July-August timeframe, which enabled storage providers to segment their Lotus miner process from their markets process. This added significant security to the network as well, because as you're accepting many storage deals, this keeps your normal kind of like participating in the network process safe and secure from any faults or DOS attempts or anything that might otherwise impact. And this has been like a huge level up. Multiple storage providers have called out that this has saved their setups in multiple situations, which is really amazing. Looking at upgrades, as we mentioned, we just accepted our first FIP, and now there's been over 20 FIPs accepted into the network by tons of people from many, many different institutions. A number of them are actually releasing in the network upgrade happening next week. And so this has just been amazing to see the kind of acceleration and participation across the community. You've really made Filecoin yours, and please keep participating, because this is how we make the network better and stronger. Looking at storage costs and availability. As I mentioned, there was still really early days here when it came to storing and using the Filecoin network, and a ton of things shipped over the past year to make that way easier. The first of those was Filecoin Plus. This is kind of the way that, that Filecoin can highly incentivize very valuable storage to come onto the network. And so Filecoin Plus shipped its principles like around the time mainnet started, and then since then has scaled to tens or 20s of notaries around the world that are giving out massive amounts of data cap, which can help large institutions like the USC Shoah Foundation, like the Internet Archive, very effectively store their data with storage providers for very low prices. And this is all done through kind of a decentralized governance process across all of these notaries who are validating that these new users coming on are adding really useful data to the network. And as you can see, all of the storage providers who are advertising that they are accepting Filecoin Plus deals are offering free storage for those, which is just amazing, and a wonderful thing that kind of Filecoin can provide through the incentives of the Filecoin Plus program. We also saw in the past year Filecoin reputation systems launch, which is the thing that adds so much utility of being able to choose the right storage provider for you and not have to, do a lot of testing or validation of that storage provider ahead of time. You can lean on these reputation systems to identify who should I store my data with. And this made it much smoother and easier to get up to speed, and really increased reliability when it comes to aiming to make a deal with a storage provider. You as a client know who's going to be responsive, who's going to work closely with you on getting your data into the network. And there's been some great tools like the stuff that Phil Swan is building that are aiming to make that smoother and easier, and something that clients can just aim on the network providing to them. There's also been a ton of work that the textile team has done here, which is just amazing. And I know it's used under the hood in a ton of different places, from Estuary to a number of other groups are all using the textile bid bot, which allows you to do these Filecoin deal auctions, which are kind of a different model. Instead of clients kind of sending their data to storage providers bid on the potential deals that are available, and request to store them, which helps clients get better prices and more engaged providers. So this has been an amazing upgrade and tooling that's being released. Something you're going to hear more about in today's and tomorrow's Orbit conference is indexing, the indexer node, and indexing all of the content that is being added to the Filecoin network, making it available on the IPFS gateway and any node in the IPFS network, which can really help large scale users who are coming and storing their data in Filecoin to make it highly accessible to the entire world and community who's participating in the IPFS network. there's a ton of work that went into making this possible under the hood. So, definitely recommend leaning in, researching more about kind of how the indexer node is going to upgrade our current usage of Filecoin all over. Dev onboarding effort was tricky when Filecoin first launched, and it has become so much smoother and easier. Nowadays, you can take 5 minutes and start storing data in Filecoin, and it's just there, and it works, and it's wonderful. You don't have to run any personal infrastructure, and there's simple APIs for you as a developer to build against. And I think there's 3 really amazing new developer on-ramps that have made that so easy for users. The first is NFT.storage, which is a hosted service for NFT storage, which stores data in IPFS cluster, pins that data in Pinata, and also makes replicated Filecoin deals around the world for all of the NFT stored. A really, really amazing tool that's now available for all NFT creators and minters. Kind of a broadening of that is Web3.storage, which uses kind of similar practices, but stores any new data, is really tuned for Web3 dApp developers who are coming through hackathons, want to get started quickly, and then scale up with their applications. And then finally, Estuary, which is a new tool for medium to large data storage, which is really helping people bring kind of larger collections of data, like how Brewster was talking about the Internet Archive's data collections. And each one of these is just having massive impact. So NFT.storage has just really changed the game for persistent NFT storage. It makes it easy to avoid rug pulls, make sure your data persists, and have the principle of relying on many different sources, many different independent networks to all ensure that your data is persistent. And now it's stored almost 6.7 million NFTs, which is insane, across 6,000 users, 40 terabytes of NFT data, because NFT.storage has no size restrictions, which means that you can store massive NFTs of virtual rooms, metaverses, video, audio, all of that is available on NFT.storage, and it's used by most major NFT platforms, including OpenSea, Foundation, Palm, OneOf, Zora, MakerPlays, Gala Games, tons of groups are using NFT.storage, and it's been an amazing thing that launched just in April this past year and has already achieved this level of adoption and success. There's also Web3.storage, which is an additional tool for people who are building more applications and dApps in the Web3 space to make sure their data can easily be added to Filecoin and persisted long-term. And that's also seen major adoption. This launched just in the beginning of August, and it's been less than 3 months, and now already has over 5 million uploads. But really easy onboarding ramps, simple JavaScript APIs for anyone to get started. And you can start building one of these and get up to speed within just 10 minutes. It's really amazing. And finally, there's Estuary, which is really, has power use cases for, however large the data is you're storing. Estuary can work with you to figure out how to get it added to the Filecoin network. And it's amazing to see, over 150 terabytes of data stored. It's just, these graphs speak for themselves, really. But Estuary has become like a major, underpinning service that's used across NFT.storage and Web3.storage as well to really do the batching and deal making within the Filecoin network and make that be something that clients don't have to worry about. Looking into cross-chain integrations, really want to shout out Textile here as well. The work that they've done on the cross-chain bridges, the storage bridges that with Near, Polygon, and Ethereum that help bring IPFS persistence and Filecoin deal making directly within those blockchains and those smart contracts is a huge step up for everyone who's building within those worlds. And I think, amazing leap forward when it comes to making it easy to work between all of these different kind of compatible blockchain communities. And so I think that work has made it so much easier for anyone who's minting a new NFT, trying to store data from a smart contract to get up and running super fast. There's also a ton of cross-chain bridges with many groups. Filecoin as the storage layer of Web3 has integrations and collaborations across most of these. And it's this is the sort of thing that has made it so much easier as a developer to make sure from wherever you're building, wherever your work is running, that you can use Filecoin as your persistent storage layer. And there's been hackathons and collaborations and new features and new tools that have been coming out of each of these collaborations. And so definitely keep your eyes posted. There's always new stuff. There's also been some amazing collaborations with browsers. As you know, IPFS nodes are embedded in Brave, so anyone can access their favorite IPFS content directly from their own local node if they choose to in Brave. There's also been amazing browser collaborations across a number of other groups, and we are very excited to see more of this. The Browser 3000 hackathon that happened just 2 months ago had a ton of amazing kind of collaborations, experiments that are just kind of shaping up to like hit the whole world. So keep your eyes posted here. There's going to be more exciting stuff too. Apps and tools. There were already an amazing community across the entire IPFS ecosystem of tools and projects that were building in the IPFS space who kind of moved into the Filecoin space and really took off. Slate is a beautiful example many people use to display their libraries and photo collections. There's Ledger integrations for Filecoin. Fleek helps you get your website up on the DWeb using IPFS and Filecoin really quickly and smoothly. There's PowerGate 2.0 that launched this year, which is amazing and super useful when it comes to building distributed applications on Filecoin. Truffle made it so much easier to kind of test and as a developer suite, brought all of their expertise to IPFS and Filecoin. There's a ton of amazing DeFi use cases with the Filecoin DeFi bridge that makes it a lot easier to use Filecoin. And then MetaMask, which of course is everyone's favorite wallet tool, also has added Filecoin support. And so there's a ton of new capabilities that are available here as well. From an ecosystem momentum perspective, I'm sure Colin is saying the same thing as I will right now, but there's just been massive improvements and capabilities brought through the PL Builders funnel, from new developer resources and tools like what we just talked about, to hackathons around the world, many of them happening simultaneously that help people onboard onto the network, to grants, accelerators, and massive ways to kind of take your hackathon project and turn it into something real, something that everyone wants to use. And then finally, a whole community of ecosystem investors who are committing millions of dollars and participating in the funding rounds for the groups that are graduating from these accelerators who are excited to hit the world. And so, as you can see, over 10,000 developers so far just in 2021 have been engaged through the Builders funnel. It's crazy to see the sorts of projects these groups are creating. It's really, really powerful. And now over 60 teams graduating from 4 accelerators in 2021. That's the next cohort of Web3 building their businesses and their projects right on top of this foundation. So the ecosystem has truly taken a massive leap forward this year. And now over $50 million of external capital is being raised by third parties to contribute to these projects as well. So it's a great time to get started as a builder, building on top of IPFS and Filecoin as well. And many people are. Over 230 startups are entering the PL ecosystem, building on top of this. And it's just resulted in an amazing growth and thriving ecosystem and community that's building on top of these protocols. Last but not least, useful storage. Really, this is the true aim and mission of Filecoin, to help store the world's most valuable information. And a ton of work was done this year to take it and make it really, really easy to add new data to Filecoin. So you can see there's just like a massive acceleration in the sort of data that's being added to Filecoin. And it really is thanks to a ton of these developer on-ramps, NFT.storage, S2A, Web3, Starling, and all of the amazing, NFT marketplaces, Web3 applications, and others who are working with those on-ramps to bring their data into the Filecoin network. And this also extends into Web2. So there's a number of groups, from the Max Planck Institute to the Internet Archive, who are all taking their large data sets and storing them in this network. So from NFTs to Web3 dApps to large data, we're really turned Filecoin into being the place where your Web3 data is stored, persisted, and accessible. So I'm sure you can join me in looking back at this amazing list of accomplishments and just, mind blown. Like, wow, this has been a huge, huge, huge year for the Filecoin network. And really, it's thanks to this amazing community. In my last minute, I'll just highlight 4 amazing things that you're going to hear more about in the next 2 days for some amazing work that is coming up next year. The first is Snap Deals, which is a new Filecoin improvement proposal, which really upgrades the accessibility of adding new data into the network. It makes it easier for storage providers to take large deals, so tens, hundreds of petabytes can now get added quickly to the network. and it makes it much easier for clients to add large data as well. FVM is something you probably heard about, adding EVM smart contracts to the Filecoin network. You probably haven't heard about this, but a big theme for next year is computation in Filecoin, being able to compute over Filecoin data. So check out the MetaProofs talk that's happening later. And finally, consensus labs, scaling consensus, making sure we have chain space for all of this amazing work. So please get in touch. It's been an amazing year. It's going to be an amazing new year in 2022. Please join us in making this network as phenomenal and strong and diverse and amazing as we possibly can. Get in touch. I'm Momac28 on Twitter. Would love to chat with you about all that you're building. And thank you. I'll turn it back over to Bailey.
Thank you so much, Molly. I had said booster stage, but this is not the booster stage. This is the exit velocity stage. I know nobody really cares. You're just like, give me more Filecoin information, please. So thanks again, Molly. All of those things that she touched on, we will be going deeper into over the next 2 days. So make sure to check out the full schedule and just highlight what you want to make sure to not miss. Up next, though, did you know there are more than 3,000 storage providers storing humanity's data on Filecoin? You probably do because Molly just mentioned it. But next up, we have a recorded session with 4 awesome folks from Protocol Labs, and they're going to be discussing the improvements being made as it relates to deal making. And I know I saw some storage providers in the chat, so hey, this session is for you. So here we go.
Hello, everybody. Welcome, Orbit people. I'm Jacob. I work on the Ignite team at Protocol Labs, and I'm here with Raul, Anton, and Dirk, and we're going to be talking about the work that we've been doing this year on improving deal making in Filecoin. And so, as part of this, here's a quick overview of our agenda. We want to talk about the work that we've been doing over the past 6 months or so, and the work that we're going to be doing going forward, what improvements we've made thus far, and what improvements we're looking at making for the future of deal making on Filecoin. So kind of over the past 6 months, we've been working a lot on improving the underlying stability. Our goal is to get to a success rate metric of 99% on the network. In this graph here, you can kind of see deal making on Estuary, deal success on Estuary over the past several months as Estuary has kicked off. Raul will be showcasing this a little bit more on how and exactly where our launch has impacted that. You can kind of see it here in the progression, but this kind of showcases the work that we've been doing. A lot of the initial work on DAG Store, the storage provider runtime architecture, data transfer stability has really been around making sure that the functional layer of Filecoin deal making is working very well and that it's stable. Something that we've noticed after making this and releasing the Lotus 1.11 version is that we've kind of hit a threshold here of stability starting to work more. We're still fixing things every day, but one of the issues we're experiencing here is that we're starting to see a lot of usability problems, making sure that clients and storage providers are able to make deals when they're ready to, making sure that deal transfers are reliable enough and that folks are able to move data when they want to, and also performance. A lot of the work that we've been doing today on GraphSync has been around fixing intermittent issues. Because we've fixed so much around deal making, we're starting to max out what the GraphSync protocol was originally built to be able to handle. And so we're kind of looking at what the future of data transfer also looks like on Filecoin, whether it's improving stability of GraphSync itself and performance of GraphSync to allow more connections and more transfers, but to also open up potentially other transfer protocol mechanisms. And so we're going to be talking a little bit about that more today. And so I want to go ahead and hand it off to Raul to talk about the work that we've been doing on the DAG Store.
Hello, this is Raul, and I'm here to talk about the DAG Store. The motivation why we introduced the DAG Store is that we conducted extensive test ground-based profiling on the deal-making processes, both on the client and the provider sides using Lotus. We realized that there was a large performance bottleneck coming from Badger, which is the IPLD, which is the data store that we were using to stage IPLD data as we were moving it around between the client and the provider. And this performance bottleneck was actually even visible for small data volumes. Now, this Badger is a great database, but the issue here is that we were using it for the wrong workloads, for workloads that it's actually not well suited for. And the reality is that monolithic LSM tree databases do not scale very well for petabytes of granular, very fine-grained data that needs to be accessed on with random access. So in short, the data store that we picked was great, but we weren't really being mechanically sympathetic with it, with our access patterns. And then we had a key insight. Data in Filecoin is actually stored at rest as CAR files. So could we read from those CAR files and write to them directly? Could we do better? And this led us to explore the design space. And we came up with alternative solutions. And the one that we ended up converging towards is the DAG store. The DAG store is a sharded store to hold large IPLD graphs efficiently, where each graph is packaged as a CAR file. And these CAR files can be attached and detached in a location transparent manner and dynamically at runtime. They can come and go. And all of this is performed with mechanical sympathy, which means that we are being really sympathetic with the underlying access patterns and making the OS and getting help from the OS to actually access that data efficiently. So what were the results? We shipped the DAG store and MRA, which Anton is going to be talking about in Lotus 1.11. This was around about the end of July. And here you can see a graph of estuary deals, and it's of estuary successful deals made over time. And you can see that shortly after we launched this new version of Lotus, including these two features, the success rate just went up on a steep incline. So we're very happy about that. We think we're on the right path. And just to give you a little bit of insight for the curious people, for the curious minds on what the DAG store, on how the DAG store actually works. The DAG store is a synchronous, concurrent, and event-driven component, and it's built for high performance. As I said before, it's mechanically sympathetic with the underlying OS and the IO, and it's using techniques like M-mapping and caching to achieve this. Now, as I said, a key concept in the DAG store is the shard. And what is a shard in Filecoin? A shard is basically a deal. It is a package of data that is referenced by a unique key. And in Filecoin, this is the deal. Every deal becomes a shard in the DAG store. Now, the payload of the shard is a CAR-v2 file, or it could be an unindexed, it could be indexed or unindexed, and the DAG store is also capable of processing unindexed CAR-v1 files. The main shard operations are register to register a shard, acquire to acquire a shard for reading, release to release a shard, and destroy to destroy a shard. Now, shards are location transparent, which means they can be attached through various mechanisms like Lotus, file system, and other types. This component, the state of the DAG store, survives restarts because we persist the state on disk. And we also have mechanisms like GC to reclaim local disk space safely and efficiently. And we also introduced a top level index on the DAG store to allow us to do shard routing just based on a CID of a block that we know is present in some shard, but we don't know which one it is. And now over to Anton to talk about storage provider runtime architecture. Thank you.
Okay, hello. So I'm going to talk about the storage provider runtime architecture. To give a bit of background on the project, I have to explain how Lotus Miner worked before this endeavor. So before the storage provider runtime architecture project, the Lotus Miner process was running all Lotus Miner subsystems within a single process. Namely, these are the sealing, the proving, storing of sectors, as well as deal making. All of this was running within a single process monolith on miners systems. So the goals of the SPRA project were to split the market subsystem from the Lotus miner monolith, and in the process, increase robustness and resilience. Storage providers should not have the stability of deal making affecting sealing and proving of sectors, because due to the economics of the Filecoin network at the moment, sealing and proving of sectors is more important to miners than making deals with clients. In the process, we also reduce the attack service because the sealing process does not need to be exposed on the internet anymore. Only the markets process needs to be publicly available and to allow for connection from storage clients. We also wanted to reduce the complexity and spread the knowledge of various subsystems of Lotus Miner within the Protocol Labs organization and the community, and also make it easier to onboard new developers on the project within smaller pieces of functionality within the Lotus code base. So here you can see a diagram of how the various processes of Filecoin Miner interoperate today. So after the SPRA project got merged, the market subsystem became a separate process, communicating with the sealing miner node and the Lotus full node. On this diagram, you can see it as a light blue rectangle, and it's behind the firewall and the load balancer, basically available on the public internet so that the market can communicate with the storage clients. Lotus Daemon, of course, is also available on the public internet because it's syncing the chain. However, the sealing and the proving node no longer needs to be exposed, which reduces the attack surface. We have also laid the foundation so that the markets process can also be independently scaled in the future, if necessary, from the sealing and the proving node. You can find documentation on the storage provider runtime architecture on the Filecoin docs website, where we explain in detail how you can split your Lotus Miner monolith setup into individual processes, and in the process have reduced operational complexity. You can still use the monolith setup today, though, and we'll continue to support this in the future. If you're interested in the actual code, you can also find the merged pull request in the Filecoin project Lotus repository. You can see that that's the 6356 pull request merged a few months ago. So why is this important? Basically, we wanted to refactor the Lotus Miner monolith as part of this project in order to increase robustness and resilience of the system, reduce the possible attack surfaces, and no longer have the sealing and the mining node exposed on the public internet. We also wanted to reduce the operational risk that miners bear. Nowadays, it's no longer necessary to basically run the market subsystem as part of the Lotus Miner. So in case something goes wrong with storage or retrieval deals, this is not affecting any of the proving or the sealing functionalities of the miner. We also wanted to be able to make to introduce new features to the miner more easily and independently of critical functionality like sealing and mining. We wanted to be able to horizontally scale the market's subsystem and introduce failover. And last but not least, we wanted to spread the knowledge of the Lotus Miner within the organization and be able to onboard new developers and extend the code base further in the future faster. So next, I'm going to hand over to Dirk to talk about the data transfer improvements.
Hi, my name's Dirk. I'm on the Ignite team, and I'm going to be talking about data transfer improvements and some of the upcoming changes we're making for markets. So much of this year we've spent working on performance improvements for data transfer and reliability improvements. So one of the main changes we made was for data transfers to detect when the connection goes down and to be able to restart automatically from where they left off. We reworked the accounting system for retrieval payments so that the way that payment vouchers were processed didn't cause blocking anymore. We did some refactoring in the GraphSync transport. That's the part of the data transfer system that connects with the GraphSync protocol. And Hannah did a lot of work to improve GraphSync memory usage and reliability. So looking towards the future, as Jacob said at the beginning, we've sort of improved performance to the point where we're starting to surface some UX issues. So we're going to be focusing quite heavily on UX and extensibility of the markets process. So in particular, we want to make it easy to manage the state of a storage deal. So we'll be providing UX components, and we'll also be making the whole system more pluggable and easier to control by individual providers. We're going to make the deal acceptance filter more extensible so that it can have more parameters when it's deciding whether or not to accept an incoming deal. We want to make the data transfer protocol pluggable. So at the moment, we use GraphSync as a data transfer protocol, but some groups have been working on other systems, so it should be easy to plug those systems in. And we also want to improve the observability of the whole system, and in particular, what's happening with your storage deal. So as I said before, we want to make some UX improvements. So these two diagrams are really just some ideas we have. They're not solid proposals, but as you can see, we want to make it easy for providers to see how much they have in each fund state. So whether deals are reserved for ongoing deals, if they're locked by the storage market actor. And we also want to make it clear in the UX when to stop accepting deals because the funds are running low. And then on the right-hand side, there's some diagrams with similar concepts. We want to make it very clear when a provider can stop accepting deals because they're running low on staging storage space. And we want to sort of list all the ongoing deals, the states they're in, and make it easy to click into a particular deal and see what's going on at the deal level as it's going through each of the states that it needs to go through to make the deal. So the overall idea is just to improve visibility into the like what's going on with my storage provider and when I'm going to be needing to top up my funds or make more space in my hard drives. So now I'm going to hand back over to Raul, who's going to talk about the DealBot.
Hi again. So I just wanted to talk a little bit about the DealBot. The DealBot is an automated deal-making machine that we've been using at Protocol Labs to measure deal success rate throughout the network. And it's been instrumental in validating the improvements and bug fixes that we've been making to validate whether they've led to high success rates or not. I wanted to send a shout out to the data systems team at Protocol Labs because they actually built the DealBot, and I'm just here to talk quickly about it. Now, the next thing that I wanted to talk about as well is reputation systems. We have the Filecoin network has over 3,400 storage providers by now, and this is wonderful, but it also comes with challenges. From the viewpoint of the user, how does a user choose which provider to pick for a given deal? That is like one of the key challenges right now, and users can be interested in many parameters when selecting a provider, like reliability, latency, availability, their region. The good news is that the ecosystem has partially already solved this problem. And apps like FillRep or the Textile Bitbot and Estuary are continuously probing and measuring the quality of service of providers using their own methodology. And some of them actually publish scores publicly. However, these scoring feeds are not unified or traceable. And the Filecoin community is working hard on standardizing an open protocol for sourcing these quality of service measurements and observations from deal makers, all the way through to enable reputation providers to run their own models and post back scores, recording all of this information on chain and providing endpoints for deal making clients to visualize scores and list providers and sort providers based on the score, and ultimately choose a provider for a given deal. This work is being led by the data systems team, again, at Protocol Labs. Now over to Jake for closing remarks.
Awesome. Thanks, everybody. It's been a great year of Filecoin. We're super happy to be celebrating the anniversary with everyone. A few things that we want to touch on a bit. If you are running Lotus and you have yet to split your miner and your markets processes, we strongly encourage you to do that. You can check out the Filecoin docs on overview how to do that. Let us know if you have any issues doing that. It's a great way to protect your miner and also benefit from all of the improvements that we've made in the storage provider runtime architecture updates. Also, we're going to be reaching out to folks and soliciting the community to get more feedback on the Markets V2 UX. So please, once you see that announcement, please reach out. We'd love to hear from you and help us make deal making easier than ever, which is the path for us to really get to 99% and build a awesome network for the future. So thank you all very much, and happy anniversary. Woo!
All right, so let's continue with more talks about storage. Up next, we've got ZX, who's the Crypto Econ Lab lead at Protocol Labs. He'll be talking about Hyperdrive, the most recent Filecoin network upgrade, which is bringing about huge scalability gains for the protocol in terms of storage onboarding. And ZX are truly the coolest letters of the alphabet, so I will let him take it away.
Hi everyone, my name is ZX. Welcome to Filecoin Orbit. Today is a celebration of 1 year of Filecoin. I'm very excited to be here. I work on ecosystem growth and I lead Crypto Econ Lab. And the theme of my talk today will be putting Filecoin in hyperdrive, huge increases in storage onboarding. I think we talk a lot about, apart from all these like massive, amazing business opportunities on the Filecoin protocol and the Filecoin network, there's also lots of opportunities and potential in storage onboarding, thanks to the very recent hyperdrive upgrade. And before we start, just a few disclaimers. This is a research talk mostly based on crypto economics with data from the Filecoin blockchain. Data and charts are provided by Sentinel and Starboard. Huge thanks to both teams. Numbers can be wrong, so please do your own research and make your own decisions. And people have different private belief and preferences. Dynamics can also be complex in a blockchain network. And last but not least, past action may not be indicative of future behaviors. Without further ado, this is like, let's dive right in with a few charts, right? This is like 1 year of Filecoin celebration. I think we have achieved so much as a community and ecosystem in the past 1 year. I feel very proud to be a part of this community. So Filecoin exceeded this exponential baseline that we set at the genesis. So for context, there's this baseline the network needs to meet and achieve. It starts from 2.5 exabyte of storage at Genesis, and it doubles every year. And so that is the orange line. It's actually exponential, and the Filecoin network surpassed the exponential baseline in April, and it's growing at an increasing rate. And today, Filecoin is the largest decentralized storage network. Apart from that, the common question always come up is how reliable is this storage on Filecoin? Well, this chart is then showing what is the percentage of storage committed ever terminated on Filecoin. As we can see, like when the network first went live, there were some termination events. Given that it's pretty unstable, it's a new network, I think it's understandable. And as more storage are onboarded, there's like then you can see this percentage termination actually goes down to a pretty low level. Although I must point out, this is not exactly a reliability metric because there are many other dimensions to it, depending on the miner storage providers as well. There are many teams working on more granular metric, but it seems like fairly reasonable. And then there's also massive demand for using the Filecoin network, as we can see from the daily base fee snapshot pre-hyperdrive, right? Like this is the same mechanism as it's a very similar mechanism to Ethereum's EIP 1559. You see like lots of spike in the demand, very active network. People are using the network to provide storage services and also to consume storage services. And just to recap on some of this concept for people who are less familiar, what is gas, what is base fee, and all this stuff. So gas really is it's a common concept in blockchain. It's a measure of computation and storage resources consumed by messages. And then there are a few like adjacent concept or derived concept. One is the gas limit. It applies to both the message and also the block, right? So each message may consume up to this amount of resources, this amount of gas limit. And then for all the blocks, it can consume up to this amount of gas as well. So when people say the blockchain is congested, sometimes what it means is that, oh, all the messages are using all the gas limit in the block, right? And then this is, well, gas usage is self-explanatory. This is basically the amount of gas, which is some unit of accounting that a message has used up. And then fee cap is basically just a UX thing. This is how much I'm willing to spend per message, and then that you don't need to worry about the rest of it. And there'll be a gas premium, which is the priority fee that is paid to the miner for including your message. And then what is this space fee thing? So it's both basically on a high level, it's a poster price mechanism that improves the user experience. So you can think of it as like there's a highway and there's toll on the road, right? Like, and this toll is kind of dynamic based on the relative supply and demand of the road itself. It's very congested. The price may go up. If you think, oh, that is too expensive for me, I don't want to take it, then you like wait for a bit, or you get on a bus, right? Like you do some kind of aggregation to reduce the expense. So base fee is basically this like toll rate on the highway in some sense, right? Like it's spiky when demand is spiky, and then it grows exponentially to find this equilibrium quickly, and people may back out, right? So then the transaction fee here will be the gas usage multiplied by the base. And there's a paper about this by Professor Tim Rothgarten. And just if you take a kind of alignment why this must be burned. So like message verification is a cost that is shouldered by the whole network. So every message sender should pay the network in this like kind of a network fee mechanism. And not burning it will create some kind of incentive or collusion as described in the paper. And we also want to align the token supply with the network utility because it's manifested in the demand for using the network. So as we can see some cumulative chart, right? Like in terms of cumulative network fee, Filecoin I think processed 28 million Filecoin. Comparing to the rest of Web3, it's really among the top, as we can see from this chart on token terminal. And then there's also Filecoin total collateral lock. It's also crossing 120 million Filecoin in just a matter of days. So where does that really put us, right? We are not on the chart yet, but like, well, even Filecoin is not like a DeFi protocol, but this traditional total value lock metric, it's also among the top. So very strong macroeconomic statistics. I feel very proud of what we achieved as a community. But strong demand is not all sounding good, right? In economics, it's always a few sides to the coin, right? Like, so it also means the expensive to participate, right? This is very common complaint in the Ethereum world where, oh, it costs us like so expensive to make this transaction. And remember, Filecoin is about utility, right? It's about empowering businesses and making blockchain useful and mainstream. And so huge kudos to the team who actually did this hyperdrive upgrade about 8 months into the network that increased the network throughput, or sometimes people call it the TPS, by 10 to 25x, right? This includes research, development, and deployment. So huge kudos to the team, and this is done through like innovation in the underlying technology. So hyperdrive basically reduces this like unit storage gas usage, right? Like as we can see, you can now aggregate sectors. That's why it's called hyperdrive. For each message can contain like more sectors. So you increase the throughput in the of the chain through this kind of aggregation of snarks of zero knowledge proof. right? So you can go up to 800 sector aggregation, and there's this very obvious reduction in in the gas usage. As we mentioned earlier, the base transaction fee is the gas usage multiplied by the base fee. There are a few caveats here. We don't want to go down too much into the details. And then there are some other new concepts that were introduced to just to address some of these incentive issues. So two of these are the batch balancer and the batch discounts, right? They provide this kind of balancing dynamic for the base fee based on the network demand. Basically, what this is saying is when the network is at capacity, right? Like we incentivize more aggregation to free up more chain throughput. And then you also share the cost reduction with other messages, so such that making deals, we want that to be cheap. So based on the parameter that we recommended the last time, we are expecting this equilibrium base fee to be around 0.15 nanofil. And here's some illustration of how this might work. When the base fee is low, the unit economics actually favor just adding single proof that use more gas. And the base fee catches up to some level, which is what we call the crossover base fee, or this, which is this equilibrium. Then you start to see this shift in the unit economics, right? It's actually more favorable to aggregate. That will free up more of the chain capacity and then bring the base fee down and makes it cheaper. And in the event that it becomes so expensive, even though we don't think you will reach this level, well, you might, but people can always aggregate to free up more capacity, because base fee, as we mentioned earlier, it's a result of relative supply and demand of the network. So then when you will aggregate even more and you free up even more chain capacity and further reduces the base fee. So let's take a look at some of this result of the hyperdrive and see how some of the key metrics perform, right? So here is the base fee snapshot, right? As we can see, the daily base fee has come down very significantly with much lower variance, right? And this is, as mentioned in Professor Rothgarten's paper, right? Whichever price discovery mechanism we've used, it does not really address how high the base fee might be. That is actually a scalability issue, and this is exactly that, right? Because the protocol introduced a 1025x increase in the supply of this capacity, which is quite unheard of in the Web3 world, right? Like this kind of actual scalability improvement that is enabled through underlying technological innovation. And I feel very excited, and I can't wait to see what other you guys will hear a lot more about all these new other development that the teams are working on. So the direct result of that is it's much cheaper to provide storage on Filecoin. This is the chart on the unit sector addition cost. Sector is just a unit of providing storage on Filecoin, right? It was very spiky and pretty high, and then with hyperdrive upgrade becomes way cheaper, much lower variance to provide storage on Filecoin. And then the storage onboarding has almost doubled. This is a very big increase. And then we see more recently, it's coming down a little bit because a lot of our storage providers are migrating across borders to provide better storage services. So this is very good result. And because from the previous chart, it's so much cheaper to add storage today, right? There's still lots of potential to grow in terms of storage onboarding. And then we look at how we remember the number just now we mentioned, right? We can aggregate up to 800 sectors per message. And then we want to look at what is this, how much are we really leveraging this aggregation as a network today, right? From this chart, it's an average with a star because the ideal metric here could be median, but we only get to an average after removing some of the outliers. So right now the level of aggregation is between 15 to 30, but we can actually go up to 800. This is a huge potential to grow. And similarly, there's another because in terms of the block reward, in terms of how each storage provider earned their block reward, it's really based on the share of the quality adjusted power. Another big lever here is Filecoin Plus. And earlier this year, just a couple of months ago, during the Filecoin Plus governance call, the community has decided to trying to increase the amount of Filecoin Plus on Filecoin network to 500 petabyte. And that is another huge potential to grow. And as I mentioned earlier, because when there's strong demand for using a network, which is good, but we also don't want it to be too expensive. That hurts the utility of the network. And with the hyperdrive upgrade, with the base fee reduction, right, it's way cheaper to use the network, and we see actually much greater adoption. It's also growing exponentially in terms of the number of active Filecoin Plus deal, the size of active Filecoin Plus deals on the network. Just to also recap a bit more about like the dynamic in terms of the block rewards. Now that we are past the baseline, like baseline is actually another innovation that the crypto econ team has done, which is also basically a KPI-driven minting mechanism. We're seeing that getting more and more adopted across the Web3 world. Now that we are above the baseline, basically what that means is that the network as a whole has achieved the KPI. So we follow this traditional Bitcoin style minting, which is like there's a fixed total pool. It means according to how much power, whether it's hash rate or storage that is on the network, each storage providers are earning proportional to their share of the quality adjusted power. So what that means is if storage providers are adding more than the network average, they get ahead, the rewards increase, right? If they are just adding about the same as the network average, they just keep up, the rewards stay the same. But if adding less than the network average, they fall back and reward decrease. So what that means is like storage providers should increase the QAP as much as possible, and they can do that through the two of the following ways: either through stealing more Filecoin Plus deals that give them 10x in the quality adjusted power, or they can steal more new committed capacity sectors. And just to like go over that again, the two charts. Aggregation is still somewhat underutilized, right? There's huge potential here, massive gain to go from like an average of 25 sector in an aggregation message to get closer to 800. And the beauty of the balancer and discount is that even if you onboard, let's say 10x of the storage as it is today, right? Because of this balancing dynamic, the incentive is to aggregate. You might still observe a similar amount of base fee, which means that like the unit cost of adding a sector can remain relatively flat and predictable. The second big opportunity and big potential here really is to onboard more Filecoin Plus deals and make more Filecoin Plus deals, and then from 1.2 petabyte to like 500 petabyte, this is a massive increase. And just to review this like stages of the economy that we talked about when we a year ago when we first launched the network, right? I think we are way past stage one, and all these blockchain networks and economy, they are evolutionary system, right? We're way past stage one. We build the capacity, people optimizing the workflow, secure proof. We demonstrate the storage is reliable, and then we are now kind of like in stage two where this like utility is growing very rapidly. The chain become more scalable with hyperdrive, reduce cost, and then like more efficient proof, right? Because of the smart aggregation, people starting to work on retrieval, making it more efficient. In terms of the minting, you have both the simple and the baseline minting working together, right? So this is where we are in the Bitcoin minting dynamic, and people are starting to work on quality of service and trying to attract paying customers. So from my point of view, we talk about this in some other talks, right? Like affordable storage at scale on Filecoin should be a given, but I don't think like for our community and ecosystem to succeed, it shouldn't be just about cost, right? It should really about that experience. And I think Filecoin is really unique among all the layer one protocols because we bring in this entirely new building block, verifiable storage at scale with proof, right? Like there's bound to be some unique experience that we can create. There are many talks on this, and there are many teams working towards this same mission. I feel very honored and very proud to be working in the same direction with you guys. And lastly, just to recap some of the key takeaways, it's really a record-setting year for Filecoin, even though it's just our first year and we are just getting started. It's the largest decentralized storage network with reasonable reliability guarantee, very strong macroeconomic statistics in terms of like protocol revenue and value lock. It's also one of the fastest scalability upgrade that I've seen in the past like 5 to 6 years in working in Web3, right? And it's also done through underlying research and development, right? This is a big achievement that we should feel very proud to. Filecoin Orbit is the right moment to celebrate. You'll hear all the people behind all this amazing upgrade talking about what they have done and what are in stock in the future. And also huge increases in storage onboarding. And there's, as we saw from the chart earlier, this is just getting started. There's still like another big step, orders of magnitude increase ahead of us. And last but not least, we are in this cooperative and competition kind of landscape of all the participants. We are all incentivized to outpace the network. And with that, happy 1 year of Filecoin, and let's continue to make history. Thank you.
Awesome. Thank you so much, ZX. Awesome talk. Next up, we are bringing Dr. Giannis, and he told me not to say his last name. So, because I don't want to butcher it. So he'll tell you his last name. He is coming up next on this virtual stage. He is a research scientist at Protocol Labs and part of the Resilient Networks Lab, where he's working on identifying and addressing the future challenges of the Web 3.0 stack. And that includes IPFS, libp2p, and Filecoin. So in this presentation, Giannis is going to walk us through the steps taken to measure IPFS and the Web3 stack broadly, and the results that have been gathered. So this is a data session, which is one of my favorites, to be honest. So Giannis, you're up next.
Hi, everyone. Very nice to be here. Thanks for the great intro, Bailey. So indeed, my last name is a little bit unpronounceable. So my name is Yanis Psaras, and I'm a research scientist at Protocol Labs. And today I'm going to be talking to you about measuring the Web3 stack. So when it all started was a great workshop that we organized back in June, which was called DI2F or DIF more simply. And it focused on decentralizing the internet with IPFS and Filecoin. We had great sessions with top researchers and scientists from around the world. We had demos and a hackathon that was organized as part of this. And we had some great results. One of them has been the Nebula crawler, which was designed and implemented by one of the community members. So you can find the link to the GitHub repository up there. And that was a crawling tool. So we started doing something that was long overdue. So crawling the network more systematically in order to find out what's going on actually inside the nuts and bolts of IPFS. The crawling tool runs every 30 minutes, roughly. And what it does is, the unique point is that it does not only crawl the network, but it's also monitoring the network. And from the first moment, we started realizing that we're seeing some concerning points, such as many online peers, but very many peers that were offline when we were monitoring the network, just after crawling the network, basically. And that could have been due to a number of reasons. It could have been because we had very unstable nodes, because nodes would rotate their multi-addresses, or hydras were having some problems. And as you know, the hydra boosters are prevalent around the IPFS DHT network. We've also seen that many peers rotated their multi-addresses to the point of having a different multi-address coming from the same IP address more than 5,000 times within the space of 1 week. So as I said, we did something that was long overdue. We had to design a more systematic approach to do measurements on the Web3 stack. So that includes IPFS, it includes Filecoin, and it might include other networks in the future. What we now have is tools that can go on and do continuous measurements on the pairs of the network in a fully transparent way. And we can have, we do have an architecture that is basically split in 3 different parts. We have probes to collect data, we have backends to store the data, and we have a processing engine that can basically give us all the information that we need to know in the end. So our crawler, Nebula, in this case, is Dockerized now and can run in several different places, several different points in the globe. So we decided to take two main directions. Measure the churn rate of the IPFS network, which is something that was not very clear before. There were measurements and statements you find online, but nothing to say how much that is actually. And that's something very important because it drives the design and the protocol setting for the DHT, and not only. It goes into defining other parameters of the network. And we also decided to measure the latency of the whole cycle from the content publishing in the IPFS network to retrieving content as a client. And of course, we've got several future directions. We're already working on them. This is just a sneak peek of what we're doing right now, the results that I'm going to present. We're soon going to be making all that public in a nice way online in reports, but also separate websites. And we're also we have started work on extending our studies to the Filecoin network, the Filecoin, the Lotus DHT, and so on, the retrieval network of Filecoin, and so on. So there is lots more to come to what I'm going to present in the next few minutes. So starting from the churn rate in the IPFS network, our results show that the churn rate in IPFS is quite big. So we see that around, like if you dig into this graph, you're going to see that around 60% of the DHT server peers stay online for 1.5 hours or less. And similarly, if you go a little bit further down, you see that 80% of the DHT server peers stay online for 3 hours or less. So we consider this to be quite high as a churn rate. It's almost as high as we've seen BitTorrent, the BitTorrent DHT reports from the BitTorrent DHT about 20 years ago. And on the bright side, we realized that the settings that we have for the IPFS DHT are very correctly set. And they manage to provide lots of resilience to the network. This is results about the resilience that I'm not going to talk about today, but we are going to publish in the near future. So we wanted to understand the churn rate in the IPFS network a little bit more. So we decided to see what percentage of nodes is stable and what percentage is those that are kind of coming and going. And we also wanted to see how often nodes go offline. So a node is coming online, for how long does it stay before we can assume that it might go offline again and therefore not be reachable. So we have split the overall nodes by running, that's one of the experiments. As you see here, it runs from it runs for about 2.5 days, a little bit less than that. And from this experiment, we found out that about 14% of nodes are always online and they're very stable. There is a very tiny percentage that we're seeing in the initial crawl of the network, but we're never seen online again. So that's about 0.6% of the network, which we call the always off nodes. And then there is the vast majority, which is about 85%, which we call the dangling nodes. Those that are going online and offline in small time intervals. So that's a big percentage, and we wanted to dive a little bit deeper. So we went on to ask the question, for how long do nodes go offline and for how long do they stay online? So in this graph, you can see the node counts on the y-axis and reliability on the x-axis. So let me explain for a minute what this x-axis means. We can go here and see the amount of time that this experiment was running for, which is about 53 hours or something. Basically translates to about 30 to 100 minutes. So if we go to this first spike there, which is just above 2,000 nodes, we see that those nodes stay in the network for 1% of the time. 1% of the time, given the experiment duration, is about half an hour. And that's a very large percentage. We can see that other nodes go from then on, obviously, the node counts go down. And so, for example, we see that here we've got about 400 nodes in the 20% online time mark, which means it's about 10 hours. So about 20% of the nodes in the IPFS DHT stay in the network for 10 hours or less, at which point they go offline and then might come online later on. So we started thinking, so we need to dive deeper. What is causing this? And we asked the following questions that you see in this slide: whether nodes are running on unreliable home machines, whether nodes that run on those home machines turn off at night, which is something very normal to do for a normal user. And we have some questions that we're still getting results for, whether nodes are rotating their peer IDs, which could be intentionally or unintentionally for other reasons, such as bugs and so on. So we went and we measured those three different types of nodes, the all nodes that, basically includes both the always on nodes and the dangling nodes. And we tried to see what infrastructure they're running on. We found out that there is, here the blue slice is 10% of nodes that run on DigitalOcean, about 3% that run on AWS, and a tiny percentage that runs on Azure. And there is a very big percentage, 85.8%, which is unknown. So this is home machines of users, or it could be cloud environments that actually have not made their IP addresses public. So we don't really know if it's cloud infrastructure or not. Then we split those to always on nodes and dangling nodes. And we see that those nodes that are always online, the percentage of them that run on cloud infrastructure is a little bit larger than the one that I just presented above. And this is normal. When nodes run on cloud infrastructure, it's much more likely that they stay online for longer. Still, however, there is a 73% of nodes that run mostly on home machines. For dangling nodes on the right-hand side, we see that obviously now this increases and is very similar to what was presented before, with 87% of nodes, almost 88, being on non-well-known cloud infrastructure. So this gives us a very good footing to say, at least that the churn rate can be attributed to unreliable home machines, although we still have got experiments ongoing to find out more. There is a great result out of this to say that IPFS infrastructure, a decentralized storage and delivery network, does not, for the most part, run on centralized cloud infrastructure, which is enabling the fact that there is no single point of failure, which is the vision for all these technologies. Now, on the next question, we wanted to find out whether nodes that might be running on home machines turn off at night. And without going into too much detail about how we define the correlation, on the left-hand side, this graph is showing the uptime when the points in time when nodes go offline, and this is related to daytime. And on the right-hand side, we can see nodes that go offline during nighttime. We see that these two look pretty similar, and based on the correlation pattern that we have picked, we conclude that actually it is not the case that some peers go offline during nighttime. That was for a specific location, obviously, and in this case, it was for Hong Kong nodes that were based in Hong Kong, because we obviously have to take into account the time of day. So we need to differentiate between different time zones. Now, going on quickly to the latency of the whole cycle from publishing content to retrieving content in IPFS, we wanted to break this down into several different steps. And obviously, the first one is the content publish time. So in this graph, we can see the distribution of content publishing. So the count, the y-axis here, is the number of items that we have tried to publish on the network. And on the x-axis is obviously the latency that these two. Now, this, as you know, is broken down into the DHT walk latency in order to find the 20 peers that provider records need to be replicated, and the put latency, where we actually put the actual provider record to those 20 chosen peers. These results are literally been in the oven right now, and we are going to be releasing them pretty soon. But that's to give you an idea of the level of detail that we're going into. Now, going to retrieval latency, we find out that we have the DHT walk that is depicted in this picture. And again, on the y-axis, we have the count, as in the number of items that we have tried to retrieve from the network. And on the x-axis, we have the latency. We need to carry out more of those experiments, but for now, it looks like at least on the retrieval side, things are being improved a lot compared to the state of things a few months ago. This is a huge win for the developers, both PL supported and the open source community, of course, that is providing all those, that is doing all those improvements to the protocol stack. We have also tried to find out some interesting insights going into further detail. And for the provider records where we see that the put operation is failing, we wanted to figure out why is it failing and what are the agent versions that are causing this. So we see in this graph here that out of about 1,300 record put attempts, these are the agent versions of which have failed. We see it's about 36% on Go IPFS nodes, 31% in Hydra Booster nodes, and so on. So this gives us a very good insight into going and debugging what is going on there, which is a very important thing to do if we want to improve the performance of the network and make it brighter and better. So with this, I'm going to finish here. I would like to mention that we have lots more coming in very shortly. So follow up, get in touch, and we're more than happy to collaborate with more people from the community to dig deeper, find more insights, and actually try to build more robust protocols, high performance protocols, and resilient protocols. Thank you very much.
Awesome, Yannis, thanks so much. And it's like not a silent P, but a quiet P. So now I know how to say your last name. Awesome. Thanks so much for joining us. For everyone who is tuning in on Hopin and on YouTube, I guess, as well, we're going to cut to a short break and then we'll be back with a keynote. All right, thanks for holding, everyone. We are back. We are back with a keynote fireside chat with Chainlink's Sergey Nazarov and Filecoin's Juan Benet. Let's do this.
Welcome, everyone. I'm super excited to be speaking with Sergey today. Sergey and I go way back for many years. We were both starting our respective projects and have been collaborating for throughout this whole time, building different pieces of the tech stack and watching so many amazing teams build upon our tech together. So really excited. It's a huge privilege for us to have Sergey with us chatting. And I'm really excited to get to dig into oracles, how oracles connect to storage networks, how Chainlink connects to Filecoin, and all of the amazing things that people are building with our networks today. So yeah, let's dive in. And thank you so much, Sergey, for being here with us. So I figured we could start with just some good introduction for people unfamiliar with Oracle networks. Can you tell us what decentralized Oracle networks are?
Sure, of course, Juan, and thank you for including me, and always my pleasure to chat with you and the great community of people that you've built here. So decentralized Oracle networks create consensus about a different set of topics from blockchains or decentralized storage solutions. So blockchains create consensus about packaging transactions into blocks, whereas decentralized Oracle networks create consensus about external data, random number generation, certain amounts of off-chain trust minimized compute through something called keepers. So basically all the computation and validation of data that blockchains don't do, you can imagine that an Oracle network does in some way. And what that does is it provides a critical set of services that then get consumed in the smart contract code to expand the universe of what's possible. The first use case of Oracle networks, which we essentially pioneered, which is kind of why we have this position in terms of adoption, is around data. But I think it's important to note that it's not just about data. It's actually about off-chain trust minimized consensus about many different topics that a blockchain doesn't generate. And it's kind of just applying decentralized consensus to a different set of computations and data validation problems, basically.
Yeah, and so you mentioned a few services there that Oracle networks provide for smart contract networks. Are there other services that can you make it sort of concrete? What are the kinds of services that that smart contracts might pull into? So things like data feeds and so on, but are there other kinds of things that make interesting networks? Like I've seen randomness and things like that.
Yeah, so there's kind of a progression now in terms of what's the most in demand and is kind of usually a gating issue type of service to make an application. So usually an application that's popular. So it actually started out with market data, and that began to power a lot of DeFi and still powers a lot of DeFi and helps DeFi grow, because having data from Oracle networks is kind of a precondition for DeFi markets and applications to even kind of really come into existence in a secure way. Then it's gone on to the long tail of data. So the long tail of data is just many different other topics: weather data, sports, elections, any number of other data sets. For example, today we had some great news that the Associated Press is launching an official Chainlink to provide their data about economics and their data about various other kind of real world events that previously have not been in a blockchain at that quality and in an assigned form. And then it also expanded to various smaller computations. So random number generation is a great example. Our random number generator is the verifiable randomness function that we have is actually verifiable on chain. So it provides a lot of reliability to games and NFT generation events and so on. And then from there, computation has really grown to include something called keepers, which is doing more general purpose computation, starting with DevOps tasks And now we're actually applying Oracle networks to cross-chain communication and token movement, both. And so all of these kind of problems, they really just require a form of decentralized consensus about the validation of data, the generation of randomness, the execution of a DevOps task, the transition of messages and information or tokens between chains. And so that's been the progression. It's been data, it's been validated data, computation, and now moving on to cross-chain messaging and token movement.
That's awesome, and congratulations! Really exciting on being able to pull in all of this real-world rich data, from different economic facts and election results and so on. Like that's super cool. Digging into the data feeds, are there kind of one of the things that Filecoin is really good for is just massive scale data storage. So are there any kind of like interesting data feeds that are like really big, or any kind of like large data sources that you're excited to be able to tap into?
Yeah, so I know that the Filecoin network continues to grow and holds many valuable data sets, and there's a lot of work there around how do you get the data out of the Filecoin decentralized storage system into powering various smart contracts. There's weather data, IoT data. There's a number of different exciting data topics that I think are useful and going to be and are being used for various more advanced smart contract use cases. I think there's also something to be said about the ability for Oracle networks to use decentralized storage as a for persistence, basically as a persistent data store, because once again, the Oracle networks, their goal isn't to generate blocks of transactions. Their goal also isn't to generate a form of consensus for persistent long-term data storage. Their goal is to just kind of generate the consensus around the validation of data or a random number or a DevOps task or cross-chain movement or something. And the actual persistence doesn't really want to stay in the Oracle network. That's not going to be as efficient, and that's not really the point. And really, actually, I think it's important for different projects to carve out and really focus on in a very clear way on specific parts of the decentralized stack. So I see Oracle networks and various Chainlink networks getting substantial amounts of data from Filecoin. I see them writing substantial amounts of data into the decentralized storage network that is Filecoin, getting the benefit of decentralized, persistent storage. And beyond that, I think there's actually a lot of other interesting combinations where you can basically verify certain things on the Filecoin network and prove that they're there, maybe without having to move all the data elsewhere. And just a lot of other interesting combinations. One interesting one I saw recently was providing insurance for Filecoin miners to create certain guarantees that the Filecoin miners will actually be guaranteed to retain the data at a certain service level. So I think there's a lot of collaboration, because what I see from what I see from the projects that tend to do a really good job at building a focused part of the stack is that they focus on a part of the stack. And so that's where I think both of our approaches are very similar, in that we've chosen the part of the stack, and we've really focused in on doing that to the most secure and decentralized degree possible.
Yeah, it's fantastic what becomes possible when you start coupling the ability to pull in lots of data and facts about the world in larger scales, and you're able to connect that to the computation of smart contracts and so on through oracles. And this is like really building up to something extremely powerful for the whole world. You described it as sort of like the truth machine. Can you tell us about this broader concept and how these cryptographically secured systems and cryptographically verified systems are going to fit into helping solve large scale problems in the world?
Sure. Of course. I don't know exactly when this is going to happen. I know that adoption of decentralized services, both in the storage format and in the Oracle network format, is happening now at greater and greater scale. I know that enterprises are using smart contracts more and more. So those two things I know are happening. The dynamic of the truth machine and the value of cryptographic truth, I think, really depends on the point at which society decides that it's important for a certain part of society to work a certain way. And what I mean by that is that the way that society works in many different specific verticals or industries or ways of doing things in like specific formats, whether it's ad networks or social media or trading or real estate, is the dynamic is pretty much, we told you one thing, we did another. We told you one thing, and we did another again, right? So recent examples are Evergrande, right? Evergrande, the big real estate developer, told people one thing, did another, because nobody really knew what solvency was. In the Western kind of part of the world's internet, Robinhood said one thing, did another, right? A little bit less recently, Wirecard in Europe, payments network, basically committed fraud, said one thing but did another. And the reason that these firms can say one thing and do another is because they're not forced, they're not cryptographically forced to act in a certain way. And at a certain point in a certain industry or in a certain subset of human activity, there will be enough of these kind of, we said one thing, but we did another events. Like imagine if there were 5 Robinhoods back to back month after month, or imagine if there were like 20 Evergrandes back to back every week. People in that part of the world would decide, look, this kind of say one thing, do another model doesn't really work for us anymore. We actually need to know your solvency. We actually need a guarantee that you can't hold trading. We actually need to know that your payment network, has a solvent set of reserves. And that's when the truth machine, which I understand to be this collection of technologies, because they all kind of need to work together. The truth itself is generated through Oracle networks. It's then fed into on-chain state that defines outcomes. And then it's stored, the results or, the things that people want to be persistent are stored in decentralized storage networks, such as Filecoin, right? So the truth machine is what I think consumers and users will get from all of this work that all of us are doing. And eventually there will be a flip. And the flip will not be, hey, we want to make a crypto startup, or hey, we're an enterprise and we want to, compete with other enterprises. It'll be, I'm a consumer and I only want to do trading, or I only want to buy real estate, or I only want to use a payment system if it gives me a cryptographic guarantee.
Yep.
And that'll require private keys, the truth machine in the form of oracles, smart contracts, and decentralized storage. And when that flip in society happens, that's when it's going to be like email, right? If you don't have email, good luck conducting transactions.
Yep.
It's going to be the same dynamic, except for this cryptographic truth.
Yeah, looking forward to that future. And I think one of the things that is going to help us get there, that I think a lot of people are super excited about, is Chainlink 2.0, and that brings out in sort of these hybrid smart contracts and so on. Can you tell us a little bit about that? How do those work?
Sure. So hybrid smart contracts are the name we have in the paper for the more advanced version of smart contracts, which is actually a collection of different systems and cryptographically guaranteed services that make the advanced version of a smart contract, right? So the definition of a smart contract over time has expanded, right? When you and me started, a smart contract was one piece of code that did one thing, probably generate a token. It didn't have a multi-sig, it didn't have a DAO voting contract, it didn't have a bunch of other contracts, right? Now the definition of a contract, well, not now, but then the definition expanded to, hey, it's actually this token contract, and it's a voting contract, and it's a multi-sig, and it's all these different contracts. Now it's expanded to all those contracts and some off-chain services, right? Some trust minimized off-chain services in the form of Oracle networks. And now there are smart contracts that use many different pieces of on-chain code, some Oracle networks, and a decentralized storage solution. And I think what's going to continue happening is that the amount of services, the amount of on-chain services, off-chain services, decentralized storage solution services that are cryptographically guaranteed and can be combined into more and more advanced configurations and more advanced use cases is going to grow rapidly. And so this is what's going to generate all those permutations of different use cases, because it's actually a very logical model, right? If you look at Web 2.0, Web 2.0 isn't just some core code somebody wrote and that's it, right? Web 2.0 web applications that function at a high level of value for users and at scale and speed and security, they're composed of hundreds of services, right? There's a ton of internal services that were written. There's a ton of external services from different places, right? So what a hybrid smart contract is a smart contract that isn't just about, hey, there's this piece of on-chain code or there's these 2 pieces of on-chain code. It's, hey, there's these 5 pieces of on-chain code over here. There's 20 other pieces of on-chain code and 20 other chains to take people's money and give them back yield. There's 5 Oracle networks, all performing different functions, 2 giving data, 1 generating cross-chain interactions, 1 generating keeper events, 1 generating some kind of anti-fraud mechanism. And by the way, everything that's going on is being persistently stored in a decentralized storage mechanism, like Filecoin. And this is what a hybrid smart contract is. And logically speaking, right, and it's not even logically speaking, this is what DeFi is, right? DeFi is a hybrid smart contract, which is partly why DeFi uses so many oracles, because without oracles, DeFi can't exist. So all of the more advanced use cases are going to be hybrid smart contracts. And the interesting thing is that those failures, like the Robinhood failure, basically brought in a crop of people that weren't necessarily interested in tokenization. They were interested in using a hybrid smart contract that's called DeFi. And so in my experience in this industry, that's really the first time that I've seen people come into our industry in mass, not for the purposes of, hey, I want to get a token, buy a token, hold a token, sell a token, whatever a token, but I want to interface with a different way of doing things in a trust minimized manner. And I think that's a very, very significant difference from previous spikes in demand and usage of the technology in this industry.
Yeah, extremely well put. And speaking of use cases, part of what is going to help build out the Truth Machine and it's going to leverage the hybrid smart contracts and all these APIs that people are building over time is developers out there. So we have both the Chainlink community and the Filecoin community have many thousands of developers, probably tens of thousands of developers together, and those developers experimenting with the tools and the tech and so on, coming up with new use cases, coming up with new applications, and experimenting is what ends up building the new kinds of applications that are going to flesh out and improve the world and make the Truth Machine have an impact. Something that we've been spending a bunch of time doing in the last year is sort of fleshing out this builders funnel to help builders out there try out and experiment with different kinds of technology and different kinds of architectures and so on, and provide some time and space for them to hack together, and then from then go on to graduate into accelerator programs, and from there go on into raising funding through venture capital and grants and so on. And one of the coolest things that's happened is these Chainlink Spring Hackathon earlier in the year had like this record-breaking developer turnout with around 4,000 signups, 140 project submissions, participants from 170 countries. It was a huge success. And one of the really cool things that happened out of that was many of those of the participants in that hackathon went on to develop their hacks into applications and businesses, and went into one of the several accelerator programs. And I think 9 of them, at least I know of at least 9 participants in the Chainlink Spring Hackathon that went on to the Tachyon cohort accelerator. So cool ones that I'll mention include or these 9 are like WeatherXM, which is a weather station Oracle network, Fractio, Tamago, Bodo, Skill Wallet, Nifty Royale, 0x Essentials, Blockbets, and Chester. So I'm mentioning these because they're they're example builders and example applications that came out of that hackathon, and they are now off to the races building one of these applications, helping improve tech and improve use cases and whatnot. And tomorrow, I know that your fall hackathon is starting, and that now went from I think 100K in prices in the last one, to 500K in prices. So tell us about the hackathon tomorrow.
Yeah, sure, of course. It's at over 500,000 in prizes now. I don't even think it's just the prizes. I think it's the fact that there's a lot of mentorship. There's people from Google. There's people from a lot of different large and small organizations that can help both very early developers and later stage developers. And you're absolutely right that I've been really impressed the amount of hackathon projects that actually continue to live and continue to exist as not only participants in various incubators, but end up actually raising substantial multi-million-dollar rounds. So we've had multiple people raise multiple multi-million-dollar rounds from the previous hackathon, and this hackathon seems to be substantially larger, like anywhere from 50 to 100% larger in terms of the prizes and the size of the amount of developers. In any case, I think that our approach to all of this is that the developer community is really going to take the infrastructure that you and I have worked on for many years and turn it into something useful. And so our goal should be on enabling that group as much as possible through a number of resources, technical resources, services, decentralized storage, mentorship, educational courses, a path to raise money for their project. And I think the fact that that's actually happening is quite impressive, because at the end of the day, it's going to be the developers that actually use all of this infrastructure that's being built by our community and your community, and even the combination of that infrastructure. It's going to be those developers that create the use cases that bring the value of all of this to the average person in developed, emerging, and various markets. So, I really appreciate the way the Filecoin community approaches supporting developers, and we have a very strong focus on that as well. So if you're very early in your career in terms of learning smart contracts or learning how to build decentralized applications, you should attend the hackathon and get going, because there are people that started that way and now have actual projects that got funded. And if you're far along, then there's a lot of cutting edge presentations from top protocol teams and various other kind of benefits to doing the experience track. So I encourage everybody to go check it out, and it's going to be I think it's going to be pretty cool what comes out of this one.
Yeah, it's a huge success so far in all of the builders in the last hackathon. I can't wait to see what people are going to build in this one. It's super exciting to see all the participation, and I think this will just continue to compound well into next year and the year after that, and so on. And I think we can really build up a really great application, kind of like reactor, where people can come together, experiment with the tooling, get mentorship, try things out, build something, and if that thing has legs and it can be successful, then go on to accelerator programs and raise funding and so on. So yeah, definitely participate. Reach out to us if we can be helpful, and so on. Are there any applications that you would love to see built in the hackathon? Any ideas that you would throw out there?
Yeah, so I think there's two categories that are still underutilized but have a lot of potential. One is something called Chainlink Keepers, where you can actually do certain amounts of off-chain compute in Oracle networks called Keeper networks. And that actually greatly expands the scope of what you can efficiently build in the form of a smart contract, or a hybrid smart contract, as I defined it earlier. And the other one is the individual data providers that sign data right now and provide it from themselves as a data provider. As I said today, and the Associated Press announced that they're launching their own official Chainlink node, and so you'll be able to get election results, GDP, inflation indicators, any number of pieces of data. And so there isn't just market data, and there isn't just randomness. That's kind of the spike in the long tail, but then there's the long tail of all the things that you could build using various specific individual data sources. We have data sources about real estate prices. We have data sources that can be combined into an inflation index. And I think it's the combination of these unique data sources as well as off-chain compute capabilities that aren't traditionally found on a blockchain. Those two combinations, possibly mixed with market data, mixed with the DeFi aspect, those are the permutations where I think a lot of unique and previously unseen things will come out of. And I think that there's a lot of different trust issues that can be solved through those permutations. So I would actually look at the newer functionality and the newer data sets, and I would think about, hey, nobody has ever had this data set on a blockchain, or nobody has ever had this ability to generate this type of trust minimized off-chain compute into a hybrid smart contract. How can I use this new capability to generate something new and novel? And I think that'll be impressive.
Yeah, absolutely. This is going to be a really amazing time, amazing hackathon. Can't wait to see what people make. Sergey, extremely well put. thank you so much for coming to participate in Filecoin Orbit. Thank you for all of what you and the entire team, the set of teams building Chainlink and all of the infrastructure and all of the Oracle networks are doing. It's like a really critical part of the future of Web3 and making the truth machine reality and helping it be impactful in the world. So a huge pleasure as always. Great to chat with you. It's been great to get work together for many years now, and looking forward to many more.
It's my pleasure as always. Thank you for having me.
All right, coming in here. Thanks so much, guys. You're getting a lot of love in the chat. They said that they want to see a chess match between Juan and Sergey at some point. So let's make that happen. Also, Sergey, the whole firm saying one thing and doing another. I do think that happens over and over again, all the time, every day. It just maybe doesn't get as much press. It's sort of gnarly out here dealing with traditional organizations. But anyway, thank you so much. We are going to take another small break, everyone who's tuning in. We just want to make sure you get all that knowledge sinking into your brain. But up next, we're going to break out into the 2 tracks again. So we'll see you all back here very soon. All right, we're back. Like I said, very short break. Now up next here on the Exit Velocity stage, we've got a pre-recorded session with Stephen Lee of IPFS Force. That's kind of hard to say. IPFS Force, the community that maintains the Venus implementation of Filecoin. So, all right, let's hit play.
Hello, everyone. My name is Stephen Lee. I'm from IPFS Force community. IPFS Force is the one who developed and maintains the Venus while the Filecoin implementations. So today, I want to show you the roadmap to Venus and to show you some update of the current status of Venus. And as the first, I want to show you current status of Venus in Filecoin network. As you may know, we launched Venus in Filecoin main network half years ago, and right now we have more than 70 nodes running in the main network with Venus, which is very good. And currently, the total power produced by Venus is about 200 petabytes, and all of the eligible nodes who had generated blocks, and overall, the nodes lucky number is about 100%, which is awesome. Well, we have the Venus launched, and currently we have done some programs and have been some forums to encourage more people to use Venus in the Filecoin main network. Firstly, with the help of the Filecoin Foundation, and we launched the incubation program, and we have an incubation center to continuously incubate small and medium-sized storage providers. In this incubation center, we provide some free services for the storage providers to help them to join the Filecoin ecosystem. And the first milestone, we have achieved the first milestone, and to help, I think, about 12 small service providers to join the system. And now we are launching the Venus Master Fellowship, and to help more technical people and team to join the system to improve their technical expertise, like this. And also currently we are also supporting the whole Filecoin network and upgrading. The current version is network version 14. There's a chocolate, as you know. Okay, next I will show you the various structure and modules, and for each modules, the new improvement and more update on this. This picture, I think most of you maybe already seen this in many conference or meetings, is because we have this into our document. We decoupled many modules in Venus, and provide each modules in different repo in GitHub. And here you can see that we have two categories of the modules. One is about it's on the left, which could be used by service provider to provide some service to the storage providers, and the right part is actually could be used by small or bigger storage providers to support their services locally. We have this kind of architecture for from the beginning, and in last month, in last a few months, we have updated most of these modules, and here are some new features one by one, and I could show this to you. For the first one, the Venus, which is the chain syncer to provide the chain services for our users. We have done many improvement on this. Is because we have Venus as the to support distributed storage provider, the provider pool. So here we have the Venus. We enhanced the Venus with some security features. For example, we limit user request ratio to avoid to prevent DDoS attack, and we optimize the dependency between modules and to ease the reference among multiple modules. And also we enhanced the RPC and to accommodate many users who has poor networks, and we support non-link to each user and to replace the one-time connection which is in Lotus. So all this improvement is to support the distributed service provider pool. And also based on this, we also have some enhancement in Venus Miner and Venus Messenger. For example, in Venus Miner, because the service layer could support multiple storage providers, so we enhanced that to support multiple storage providers mining control. For example, we could start mining for medium storage miners, well, and upgrading and stop that. And also we improve the CI/CD upgrading, and for each miner and each messenger, which could connect to multiple VLAS gateway, for redundancy and also for the fault tolerance features. And based on this, because we need to support multiple storage provider, from different locations, so we also need to enhance our security. So we have the VLAS auth component to do the authentication and to enhance our security of our system. This is quite different than a Lotus and more complex than Lotus. And also we have the VLAS gateway, which provides the central portal for all other modules. So people only to connect to the gateway instead of they need to connect to many modules on the cloud. And on the cloud. All of these are the shared modules. And besides that, we have the individual modules which should be deployed on site for each storage provider. So we have the VLAS wallet to do the message signature, and we have the VLAS signer to seal sectors, and we have the VLAS market to support the storage and retrieval. We also enhanced all of this. For VLAS wallet, we have some security features, especially when you to have some policy to do the address verification. For the VLAS signer, we enhanced it to automatically generate default unsealed data to save time for all of our users. Improve the sealing efficiency. And I think just in this month, we have delivered the VLAS market, and we have also have the seller to support zero data sectors, and we have the VLAS market to support zero data storage and retrieval, which is compliance with Lotus, which is good. And we have deployed this in the incubation center. So all the storage providers who connected to our incubation center could benefit from this. So this is all about our improvement about the modules, and currently we're doing continuous improvement, and with all of this new features and the new enhancement of the Filecoin network, the VLAS team also incorporate all of this change, and also we continue to refine each module of our system. Currently, we're working on more things to enhance the whole system to support our users. Here is some targets we're working on. The first one, we have the market campaign to help more people to join us to support VLAS from any other community in the Filecoin ecosystem. So we have the VLAS master program. In this program, in next 3 months, we will have a few technical guys from other community, and any one of you could apply this, and we will have some training material, and we will have some VLAS developers to work with you and to let you know how the VLAS work and how to support our customers by using VLAS software, for example, installation, deployment, and also do some troubleshooting. While we have the masters to support our clients, we could have more and more technical engineers to support the whole whole VLAS VLAS market, and also the whole ecosystem, which is good. And for the VLAS master, actually, for anyone who is a VLAS master, not only the person will get some help, some support from the VLAS team, and also you could also get paid. I think it's about 100 Filecoin token will be paid to encourage you and to thank you for support of the whole whole system and community. And the second thing is about the VLAS cluster. Currently we have the VLAS, but VLAS could support the distributed storage storage provider pool, which because they will support many clients. So we need to have the cluster to support redundancy. We're working on this and to provide a very robust system for this kind of services. And the third thing is that we are also working on mechanism to have all the storage providers could share the block rewards within a pool. Because many small storage providers, they could not actually generate 1 block per day. So their rewards are not certain. So if their power is small, they could not get reward for many days. So while we have this kind of sharing rewards mechanism, this small service providers can get rewards every day, because they share all of this. But which is a little bit complicated. So we're working on this. And I think perhaps we will have that available in next month or so. And also more about this is because we have the all these components decoupled, and all these components could be composable. So for each component, you could to develop it or polish it and make it powerful. There's all of them are independent. So we will continue to improve each module, and we also ask other developers in the community to help us to develop any modules you like. So while we have these modules, we have the standard API for each module. So for each module, improvement will also improve the whole system. And also a very another thing that's very important is about this storage and retrieval market. For this one, we just achieved the milestone one of this market is because the current one only provide very simple functions, which is complete with Lotus. Yeah, but but with us as a distributed storage provider pool, we could have a powerful market which could installed in the as a shared module to support million small storage providers. So yeah, we're also working on this. Just stay tuned, and you will see we'll have more features and more release coming. Okay. Working with us, this together to build a better Filecoin. Thank you.
All right, next up, we've got a panel of Filecoin storage providers from around the world, moderated by Stefan, the lead of storage provider growth at Protocol Labs. They're going to talk to us about what a day looks like for them storing humanity's most important data. So I'll go ahead and hand it over to the panel.
All right, welcome everyone to another session at Orbit this week. We have an amazing session lined up for you today. We have 3 storage providers that will participate in a panel session on what it takes to be a storage provider. We'll address a couple of topics that are on most of the storage providers' minds these days. But first, before we start, it would be good to see what happened in the last year. So much growth happened in the network, and Jim Pick is with us here today, who built a nice overview that we're going to look at right now. And Jim, go ahead, kick it off for us. Show us what happened in the last year, starting 2020, August 24th.
Okay, so this is a visualization I made as part of my Provider Quest project, and it's I'll hit play here, and this is showing a year's worth of power growth from the storage providers. And this video runs for 90 seconds. The red providers are the new ones, and after 3 months, as they grow and grow and grow, I show them in yellow here.
Awesome.
Okay, I'm going to switch over. Yeah, I'm going to switch over to my second video, which is a different view. It's only 2 weeks worth of data, and it is public. You can see published deals, so clients storing files onto providers. And one thing to note here is I don't know where the clients are, so I've just sort of randomly allocated them around the world. And yellow is Filecoin Plus deals, and blue is regular deals. And the thickness of the lines are the size of the file or the deal, and each little one is a separate deal.
Awesome. Great to see the momentum pick up.
And if you want to actually play with these interactively, you can type provider.quest into your web browser, and it'll take you to the project where I'm doing all the data collection and visualization work. And everything's open source and all the data is open.
That's great. Love how you see the acceleration of blue as well, where Filecoin Plus is yellow, as you said, and regular deals are blue. So it's great to see a lot of blue deals as well in the system.
Yeah, it'll be interesting to see how it evolves over time.
All right, great overview, and thank you so much. So definitely the first graph, very visual, very, and the second too, but to see the growth of storage providers coming from the east to the west, and now definitely accelerating, not just in growth, but also in taking deals and actually storing useful data on the network, which is fantastic. So today, who do we have with us? We have with us Julien Noel from France. We have Jonathan Hooker from Australia and Simon Campbell from the US. Thank you, all three, of joining me today. We are very blessed to have you, and I know that you're dialing in from different continents, so fantastic to see the commitment. The goal of today's session is really just to talk a little bit more casually about what the topics are that are on storage providers' minds. So first and foremost, let's talk about maybe pricing, Julien. What I think is interesting about your business is that you're not just a storage provider, storing data, but you're also a software provider. One of the things that you've identified in the last couple of months is that there was sort of a gap, or there was tooling required for storage providers to set the price, right? As we just saw, you had the verified deals or the verified deals or Filecoin Plus deals and the unverified deals. So can you tell us a little bit more about why you built that tool and how it helps other storage providers in setting that price? We cannot hear you, Julien. You're probably on mute. That horrible mute button, I know.
Hear me?
Perfect. Now we can hear you. Go ahead.
I did nothing. Okay. I was just saying, yeah, thank you. That's a lot of question, actually. So just a bit of background, just to explain why I built that solution. So I deep dive into Filecoin because actually I was amazed by the beauty of IPFS and the underlying, which is the underlying protocol of Filecoin, and the vision. So when I started to join the community, that was as a miner, and monitoring a Filecoin miner was not an easy task. So it's basically you spend day watching a screen and night. So I didn't want to stay behind my PC all the time. So I decided just to create real-time graphical interface with the community. And now this interface is used by more than 400 miners. And I really enjoy building this tool with the community. So this is where I started to have the idea just to build another tool for the next challenge that came to us, which was the storage deals. So actually, when you start to enable storage deals, you face a lot of things. The first thing is it's very time consuming. And Lotus actually is not designed to handle a variety of clients with different pricing and different type of deals. So that's the first problem, is that you need to treat all your clients the same way. You need to communicate on site just so people know that you want to accept deals, and then you need to connect to brokers platforms so they can send deals to you. And also you need to take care of your reputation, because actually you are not just committing capacity. Now you have a relationship with clients. So it's less predictable than just committing capacity, but actually if it's well managed, it drastically increases the power growth with exactly the same hardware. So that's a good point. And also that's the finality of the protocol, is to store data, not just to commit capacity. So when actually what we design with CID Gravity is we design a product to provide through a very simple web interface a way for storage providers to manage their deal flow. So they can set pricing very granular per client, per size, and so on. They also can protect their miners by setting some deal rate limits or block specific clients or go to maintenance mode so they don't receive deals during their maintenance. And they automatically inform the brokers. So you keep your high reputation because they're not sending deals to you because they know that at that time you're not expecting deals. So we integrate the large brokers, and actually when they use CAD Gravity, you can directly receive deals from the brokers. You don't have to keep. So that's the main idea behind CAD Gravity, is just to reduce the time you spend behind your PC just to accept deals and get a very huge increase of your power. So today, during the last 2 months, we analyzed more than 650,000 deals.
Wow, that's amazing. Is it like a set and forget, right? You set your price, you can go off and do something else, and that's what I'm hearing, right?
And
it's
when
awesome.
you get a new client and you deal with him and you want some specific price, you just go back to the interface, set the price for that specific client, and it's done. And then you can just look at your report and do something else. Yes, that's really the idea. And we do that like we are not in the middle between the client and the storage providers. They are still dealing directly together. We are just a third party that the storage provider is verifying the price when he's receiving the client request, which means that we are keeping the decentralized way of Filecoin and how it's designed today.
Fantastic, awesome. No, this is a perfect example of how we can help make it easier for customers to store data and also providers to accept deals, which is what we want to hear. And as you can see, I mean, this is a perfect example, again, of evolution and innovation that happens within the storage provider ecosystem itself. Maybe shifting gears a little bit, Jonathan. Jonathan, you're calling us from Australia. You're obviously, when I looked at the map, I saw one point, a big dot in Australia. My assumption is that is one of your Filecoin systems. You have recently been accepted as a notary, so you're part of the notaries now. And earlier on this year, we rolled out Filecoin Plus, right? We saw the map of deals of Filecoin Plus that Jim showed us. But can you tell us a bit more about what the benefits are and what storage providers should be looking for when, or how to take advantage of Filecoin Plus?
Yeah, sure. So, Stefan, thanks for inviting me today. So there's some great speakers. Let me give you a quick background about Holon and the 3 divisions that will bring clarity to that question. So we've got Holon Global Investments, which is the asset management side of the business. That has an AFSL, which is our notary position. We have Holon Innovations, which is the storage provider. We invest in Web3 infrastructure. And we also have a VC arm that invests in next generation businesses. So how clients and storage providers work together gives notaries confidence in their Filecoin application, and it will energize notaries and the ecosystem to support their vision long term. If I break this down, how we do it at Holon, as a storage provider on the Holon innovation side of the business, we need to find a client that wants to be a Web3 enthusiast and that wants to go on this epic journey, right? We need a client that wants to be part of the movement. We're about to run a proof of concept with RMIT, the Royal Melbourne Institute of Technology. RMIT loves Filecoin, that it gives them more transparency and more optionality on their data storage and verifiable attributes. So with RMIT, we're designing new payment models. We're working with them. What does verifiable functionality, how does that look for their professors for this new data storage solution? And how do they ultimately use this new data storage solution? So as a storage provider, when you build this great rapport with clients, it really comes through in their Filecoin Plus application and energizes the ecosystem, right? And it kind of like this news travels through the ecosystem really fast. And at this moment in the life cycle of the network, passion and energy is everything, right? So that's really how storage providers can work closely with clients, so clients really get the best out of Filecoin Plus and the ecosystem.
That's awesome. Passion and energy is everything. I love that. So talking about business, right? Basically, if you're building a Filecoin system or you're running a Filecoin system, it's more than just running it for block rewards, right? All of us are, as you said, we're looking for people that are aligned with our mission, clients that are aligned with our mission. And maybe it's a good question for Simon. You have a lot of experience in helping startups and incubating new technologies. So you're running a Filecoin system, you're running a business, right? How do you recommend storage providers to think about their business in a way that, you know, is sort of like helping them to differentiate and maybe collaborate together with some of the startups that are being built on the Filecoin network?
Yeah, it's interesting. So as you said, Stefan, my background has been in starting technology businesses and then moving across onto that half and half, where I was helping to scale technology startups. And what's super interesting, DSM in partnership with DLTX is now building a really large kind of file time storage element. And when we think about how that's going to succeed, our success is 100% aligned with that of Protocol Labs and the entire ecosystem. So from our perspective, I always think about the end goal of the customer. So a lot of what Jonathan's talking about is really resonating. You've got to understand that a successful ecosystem has customers that are happy and you're providing solutions that they need. And so in the middle of that, you've got applications, similar, Julian's application and many others. Examples like who's going to create, the Dropbox for Filecoin and all of these other interfaces. So as a storage provider, yes, we're providing storage to the ecosystem, but the best thing we can do is to engage with the Techstars Filecoin Accelerator, the Tachyon guys, get engaged with the startups that are building applications, and then provide them with two things. Yes, investment and capital is great, but in reality, how do we help them to interface with customers? How do we help them to bring customers on board and to really test their applications and make sure that its market, has product market fit? So I would say that it's more valuable. I always, rather than investment and advice for my startups, it was practical, hands-on, go-to-market support that was the most valuable thing for them. So if we have large networks, whether it's investors, whether it's customers, how do we help that middleware layer to engage with the customers?
Great answer. I totally agree with you. Today it's like you're building a solution, right? You're offering solutions to end customers. And so, that solution is a combination of, Filecoin plus something else that truly brings value to the end user. Now, what use cases and verticals, are there any verticals that stand out, or use cases where you go like, okay, well, that is sort of like a good entry level or a focus area right now that providers should focus on?
Yeah, I think there's two parts to this. There's kind of today and then there's tomorrow, right? So today, obviously, there's a really strong business proposition for archive storage data. Startups themselves are obviously, there's a lot of startups building on top of the different protocols, on top of the blockchain protocols, and they're going to be the most innovative kind of early adopters. But then you've got a lot of archive storage data, whether it's think of the kind of the Google Earth type models. You've got universities, you've got medical facilities that just have to store data in high volumes and kind of have it sat there as data sets. I think what's super exciting kind of coming next is this compute over Filecoin space, right? When you start to say, how do you enable things like AI algorithms to engage with large data sets? So those large data sets are going to be sat in long-term storage, but then you want to be able to pull them down, interrogate them, and put them back again. And I think that's where we're going to see a kind of a huge leap forward in the ability of Filecoin to service this huge marketplace that goes beyond just that first step, which is the archive piece.
Yeah, I totally agree. I think a lot of our conversations today actually with enterprise customers or research institutes are exactly, focused on that particular aspect. And that's the lack of funding for storing, large unstructured data sets because there's just no budget, or because there is no technology that will support, the way they want to store it and the way they want to preserve it. And so, as you can see today, what we're seeing is a lot of our customers storing data on Filecoin or looking to store data on Filecoin are looking at 3 to 5 copies, right? And so that's very unique in the sense that you can distribute it. And so with any use case, any enterprise client or open data set that comes onto the Filecoin network, you automatically see multiple storage providers benefiting from that. So I would assume that this is I've seen the community to be extremely collaborative and very strong in like making this work together. So would you agree with that, Simon, that it's a very strong community and you're building relationships within the community that help us build the network together?
Yeah, I think traditionally, if you look at any large technology, you would say in the past platform and now protocol, right? It is an ecosystem play, and collaboration is learning. From a storage provider's perspective, you're never going to be the single storage provider that serves everyone, right? You need to be able to have multiple locations, backups, and through collaboration, you learn and push the whole business forward. There's a constant feedback loop with Protocol Labs, with the underlying technology, Lotus technology. And then what we're doing is interfacing. Julian's a great example of this, where he's sitting there as a storage provider saying, I have a need. And therefore, if I have this need, I think some other guys are going to have this need. And so then you can collaborate and say, we're talking to Julian, not just kind of on investing, but also saying, okay, how do we help thinking about different user journeys, right? What are the next parts of the platform? What are the things that will be the next 2 or 3 development cycles that will enable us as storage providers to do even more, but also through to the customer, at the end. So getting engaged with customers in the ecosystem is, and this energy that Jonathan talks about, right? It's exactly what happens in these early days, and that's what drives the success of the overall business. Was for it to succeed, everything needs to succeed, and we all need to succeed with it.
Awesome. Yeah, totally agree. Anyone else wants to comment on that? Julien or Jonathan? Yep. Okay, well, we'll go to the next question. Maybe let's shift gears a little bit. We have like 3,300 storage providers right now. It's amazing, right? Every day we're growing. 5 to 10 new storage providers are coming on board. You saw sort of the introduction. I want to see next year that whole map be yellow as much as we can. But if you think about the next 3 years, and in all honesty, I think it's already accelerated and discussions already are going down that direction. But if you look at running a storage provider environment, you're running a business, right? We talked about that. You're running, a service, you're providing a service to your customers. And so it's my belief that we're kind of building, these new levels of infrastructure as a service that are built on multiple blockchains. And Filecoin is sort of like the foundation, or a very foundational piece of that sort of lays the foundation for a fully decentralized data center. And so I think, Simon, you kind of mentioned it, right? You already mentioned the compute side. And so we'd love to get, Jonathan, maybe you can take this question, but we'd also like to hear from Julian and Simon on this. But where do we think the next 3 years, what do you think the next 3 years will look like for, our storage provider network? And do you kind of agree with that, approach of, us building a decentralized data center?
Yeah, definitely. If I think if self-sovereign data takes off and IPFS, Filecoin, and DAO structures come to fruition as I expect, I think Filecoin, we could see Filecoin being the world's database, which is a big call, right? But this will have a significant impact on the world. I went through my own LastPass the other day, and I counted 25 sites that have my home address, right? In Web3, where they keep all my data and they're storing it, those 25 platforms have 3 redundant copies. That's 34,000 bytes of information on one data point, right? In Web3, where I own and control my own data, and I decide to have 3 redundant copies, and where I store it, that's 1,300 bytes of information. That's a 25x reduction in the power and physical hardware needed to store that data point. And I get ownership and control over that data, right? That model will be a massive impact for the world's citizens. And if I think we're an investment firm, so we look at all the companies in the world that they're innovating in every industry. If we just look at the data creation in autonomous cars and the genomics data about to explode, as a world, we need to free up data resources for these new industries. And if Filecoin being the world's database, that kind of gets me really excited.
Awesome. Yeah, all of us definitely, now that we have more than 12 exabytes, sitting out there. It's amazing, like, as you mentioned, right? There's an explosion of data happening. It's been happening for a while, but it's only accelerating. And it's up to us to kind of convince the world that decentralized storage architectures are the way to go, and Filecoin is the foundation for that. So thank you, John, for driving that. Julien or Simon, any other comments on where you see the 3 years? Where do you see Filecoin being 3 years ahead of this?
Can you hear me?
Yeah, go ahead, Julien.
Yeah, so there is this number that said that by 2025 there will be 175 petabytes of data that are going to be produced, and the cloud can only handle 5% of it. And that means that that's a huge opportunity for us, and we bring a lot of value on that. So this is decentralization, this is control over the data, this is data verifiability. And all of this is amazing, and I really think we are going to succeed and take a big chunk of this.
Yeah, my build on that is there's a lot of innovation and build that comes on top of having a huge amount of decentralized unstructured data, right? There's the how do you structure the unstructured, how do you make it usable, how do you provide that end service, and in many cases a service that meets the requirements of new technologies and new customers. And so that's the opportunity for Filecoin, really, I think, is you haven't got the historical architectures and the challenges of like the old airlines when the new airlines came in, right? So we can build for today and tomorrow versus relying on what was there before.
Awesome. With that, I couldn't have said it any better than you, Simon. So great tagline. Thank you all for joining today. I know we're at the hour here, but I really appreciate it. Hope to see you again next year, and with an updated map, but a ton of more use cases and a ton more growth in the network. So appreciate everyone joining, and we'll see you in the next session.
All right. Thank you, Stefan, and the panelists. That was actually a really good point by Jonathan Hooker, that the data redundancies would be eliminated with this Web3 architecture. So I had never really thought of it like that. So that's awesome to hear. Our next session is definitely one of the most epic titles that we came up with: The League of Entropy, Knighting Filecoin into Verifiable Randomness. That sounds so cool. For this session on Drand, a product with the goal of being a source of unbiased randomness, we welcome Sid Signal, Drand project lead and engineering lead. Sid, go ahead and take it away.
Hello, everyone, and thanks for dialing in today. If you are looking for some randomness in your life, then you probably have come to the right place. We are all about randomness and providing it as a free service, free public service to the internet. In today's discussion is going to be more about what exactly were the motivations that we had in mind, and what sort of a gap out in the industry we were trying to fill with DRAND. So DRAND is fundamentally So DRAND is actually a randomness beacon, which can be used can be seen as a foundational internet protocol, pretty much very similar to what the other protocols we have. So as a quick introduction, DRAND is a distributed, bias-resistant, unpredictable, and publicly verifiable source of randomness. And as of August 2021, I think a few months ago, DRAND completed over 1 million rounds of randomness and actually already has 16 independent collaborators, partners who run the network. So in today's session, I only have 20 minutes to cover, so I'll not be able to go into a lot of depth about DRAND in particular, as I would like to cover, I would say, more of the breadth as to what DRAM actually is and how it's used in Filecoin, to be very honest, which is one of the biggest users and the most largest production user of DRAM. So today we'll cover, just go through some introduction about, why do we need randomness, and what are the different kinds of randomness that we can potentially use, and then go into a little bit of detail about how DRAM works, and then we look at how the leak of entropy and Filecoin provides this as a service to the internet, and how Filecoin actually uses it. So jumping into the motivation, I mean, as you can see, I mean, if in any not only blockchain systems, but various types of systems, you always need some sort of a random value or a random number that you can use for fulfilling various functions. Now, in this example, if I don't really have a reliable source, or if the number is not truly random, all the following computations kind of are pretty much pointless and meaningless. So why do we need good randomness? Randomness has many use cases, and as we have seen in public forums, we have lotteries, jury selections, elections that happen, the selection of auditors, the selection of people at the booth. So anytime you actually want to select from a large number of fair play or even players, you need an unbiased and a fair way of selecting them. So for example, in cryptography, a lot of the protocols, they actually do the leader election in like proof of stake blockchains such as Filecoin, or even for the Tor protocol. They actually need to select a particular player or an entity or a particular path in a fairly open manner, in a fair manner. So there are things like even in statistics, when you have a large data set and you want to select a sample from the particular set, you need to do that in an unbiased manner as well. And especially, nobody should be able to predict what you are going to select next. Otherwise, the entire basis for the computation kind of falls apart. So, but the point is, randomness is good, but why do we need good randomness? I mean, there are a lot of implications of having bad randomness. I mean, as we have seen in lotteries in the past, there are millions of dollars of funds have actually been rigged because someone was actually able to essentially hack into the system or predict the future values and then play to their advantage. So we saw the hot lotto fraud scandal, $14 odd million in prizes kind of rigged away. We also saw in the case of Linux systems, for example, where there's actually the encryption seed. If that can be predicted, then all the future signatures that are used for encryption can actually be forged as well, and of course it leads to a huge security vulnerability in the system. So what we talk about randomness all the time, but we didn't ever think about how do I actually get this randomness? Like, should I get it from one particular entity, or should I do it by myself, or should I go out and see if there are an abundance of other people who can actually help me get some good randomness? So surprisingly, we found that there was not really a very good or a reliable source of randomness, and that's exactly what we decided that, hey, we actually want to plug this gap. Starting with Filecoin, when Filecoin was getting launched, we said we want to make sure that we are relying on a good source of randomness, which has these particular properties: the properties of being unpredictable, of being bias resistant. That means no one particular party can actually predict what sort of or determine the types of values that can actually be generated. It should be publicly verifiable, because all blockchains, like Filecoin as a blockchain, for example, is a public system. So anybody out there should be able to publicly verify that the output was never biased in any particular way. And most importantly, with the entire emphasis of Web3 being decentralization, we didn't really want to use one single source or organization or entity as a source for the randomness. So we wanted to make sure this is actually is put together. The random values are put together and sourced from multiple places, and from parties who are fairly independent of each other. And of course, as with any internet service, we want this to be highly available. So with that quick introduction, I'll move into DRAM and explain what DRAM is and how it's been constructed. And again, with the caveat that with the lack of time, I probably need to skim over a bit of detail, but fundamentally, DRAN uses the concept of threshold cryptography, which actually allows us to combine the inputs from many cryptographic protocols to create one final value, which means that if I have a total of n participants who are contributing the randomness, I only need a threshold, which is typically, which I'll explain further, which is the minimum number of players who need to be who I need to rely upon to capture those random values and then generate a final value. And by generating a threshold signature, we can actually derive verifiable randomness in a decentralized way. We'll talk about that further. So here there are two parts, two phases for generating the randomness. One is the distributed key generation process, in which all the participants who actually want to participate in a particular round or to generate random values, they need to first agree upon a predetermined set of parameters. And the second part is where once those parameters are determined and the initial setup is complete, they actually move to generating randomness at a predefined interval, so to speak, or a frequency, where they combine their own individual partial signatures and they generate one final value. So, and this is supposed to be a lightweight and fast protocol in which we don't really want at every interval that individuals will actually have to wait for each other. So instead of that, we basically rely on achieving a minimum threshold. So if we have, and we can talk about that next. So DRAN is fundamentally, as I said, a software run by an independent set of nodes. Like there are a bunch of servers, independent servers running all over the world, which collectively produce randomness. Now, decentralized randomness, like I mentioned, is produced using threshold cryptography, in which I only need to have a threshold, typically n by the total number divided by 2 plus 1, like a majority of the number of generating nodes. We are able to bind or combine together the independent entropy sources or randomness sources into a publicly verifiable one, right? And for that purpose we use the BLS signature, and we can talk about that a bit further. Right now, DRAN has been running for over a year, and it's a production grade service. So it's tested, it's audited, and it's globally deployed. And the best part is you can actually access DRAN's randomness using just a curl call to the public APIs that we have. So how does DRAN work? Very quickly, like I mentioned, a distributed key generation ceremony. The parties or the nodes that come together or have decided to join the network, create a network. They actually define the threshold parameter, the minimum number of nodes that need to generate randomness, and the period or the interval at which this randomness is going to be generated. And once each node in this process, they generate their own keys, sourced from their own a variety of ways of generating randomness. Somebody's using a lava lamp, somebody else can use a cha-cha protocol, and each of them can actually use their independent sources of randomness to generate their own signatures. And once that initial setup is complete, we can start generating randomness ad eternum, like on a continual basis. So at every epoch, which is basically the expiration of a particular interval, in the case of Filecoin, that is 30 seconds. Each node broadcasts their partial signature to the rest of the network, and each node in that particular network, and when I say to the rest of the network, means at least a threshold T number of nodes who need to receive their signatures, and each node amongst those T collects these signatures and then uses the BLS, the Bonnet-Lin-Shakam BLS signature method to actually verify that all the different partial signatures are valid. And if this signature is correct, then the randomness is simply the hash of that particular BLS signature. So it's a fairly simple and a highly performant system. So I'll probably skip this in the interest of time, but DRAN is also a chain. It's not exactly I would say a blockchain system which relies on incentives. It's an incentive-free system, but it does have the same constructs of a blockchain, in which the values of the previous rounds is actually used to generate the value for the next one. Now, we are actually working as a future direction is to break this chain, so to speak, so not to have this dependency on past values, because there is no real impact on security. Security is entirely reliant upon the threat model. So, and this is currently a work in progress that we are doing, in which we are unchaining the randomness, so not creating a dependency on previous round values. This will actually help us to create temporal signatures, or what we in other circles call time lock encryption, in which this can actually be held. This can actually enable us to mitigate front-running attacks and MEV and those things. So stay tuned. With this, I want to jump into the leak of entropy and discuss about why this came through. So as we all know, 35 years ago, the internet needed a way to just be able to tell the time or agree upon time. So people actually built a foundational internet protocol to synchronize distributed clocks and provide a publicly available network clock, so to speak, right, with very little skew. And that's NTP, the Network Time Protocol, right, in which there are layers and layers of distribution and of generation and distribution infrastructure that distribute this information over packet-switched variable latency data networks. So it's similar to that. Today, the internet needs a way to get randomness. Just how we wanted to get time, the internet needs to get good randomness. And that's why we need a foundational internet protocol to create a verifiable, unpredictable, unbiased, decentralized source of randomness. And this should be publicly available to anybody, anywhere in the world. Well, here we go. So here is where the League of Entropy kind of helps us out. They actually came in and to save the world, pretty much from the lack of good entropy, good randomness. And essentially, the intent was to create something very similar to NTP, a foundational internet protocol called. So in this case, we call it DRAND, which is a randomness generation and a randomness distribution network that can be scaled across the internet. So we have 3 layers. We have DRAND nodes, we have DRAND relays, and we have DRAND clients. And we'll talk about that a bit more. But just a very quick overview of the League of Entropy. The League of Entropy is a global DRAND network composed of multiple independent, diversified, like-minded, savvy organizations who came together in June 2019, to form, the network. What I was talking about in threshold cryptography is the minimum set of independent parties that need to come and agree upon to create a network of T signatures, of threshold T signatures. So today we started with 10, but today we have 16 members, and we are in the process of onboarding more. And we have 23 DRAND nodes, the actual sources of randomness, which in this case obviously means that we only need a threshold of 12 to kind of agree upon the final signatures. So the goal of the League of the League of Entropy is to provide randomness as a service to the public, and it's free, completely free. Anybody can access it, just the way DNS, NTP, certificate authorities, and certificate transparency are all publicly available and consumable protocols. DRAND can become the foundational internet protocol for randomness. And with the evolution of Web 3.0, it actually makes sense that we come together, different people come together instead of trying to pick each other apart. I think we should come together and participate in this extensible and pluggable network called like DRAND, for example. So in this case, the most a key aspect of this, I would say, which I would highlight, is the decoupling between the distribution network. So DRAND is a production-ready network, but how do we scale it? How do we make sure that it's actually secure? How do we make sure that this has enough liveness or enough reach across the world? So decoupling the distribution network from the source of randomness generation, which are the DRAND nodes, was an architectural choice that we made, and it's worked out very well for us. We actually rely upon relays, DRAND relays, both HTTP relays and gossip sub relays, as well as CDNs to cache values for anybody who wants to access past rounds. And of course, with anything of internet grade, we want to have continuous monitoring. But the most important aspect here is that it's a decentralized network, which means that it's a highly resilient system. So out of the 23 nodes that I mentioned, we only need 12 to be available and be available to participate in the creation of a new network. And failure, so it's a lot more fault tolerant, so to speak. I'll probably, for the lack of time, I'll probably skip over the architecture I think I already mentioned this, so you can follow up in the slides later on, or we can take up questions next time. So most importantly, DRAN has a solid governance model. We want to make sure that we actually have a set of participants that are diverse in nature, which means that they operate in different geographies. They are under different government jurisdictions. They have their own different interests. Not everybody wants to mine Bitcoin, for example. So there's a lot of pro bono work here as well involved, because we want to have stewards, long-term stewards of the protocol. And of course, we also want them to be able to run their infrastructure, the DRAN nodes and relays, on infrastructure that is diverse, which across on-premise infrastructure or cloud-based infrastructure, so to speak. So yeah, we are accepting applications. So please reach out to us on the email provided here, and we will be very happy to talk to you and take the next steps. Very quickly, I want to talk about Filecoin. I think I'm not going to go into a lot of detail about Filecoin because this event has plenty of other opportunities for you to learn about Filecoin. But where does Filecoin get? Where does it need randomness? So Filecoin has multiple different requirements for randomness. I mean, it's actually a lot of different requirements, which some of these which I mentioned on this slide here. So as an example for today, we'll actually focus on the leader election mechanism that is actually used. And for the leader election process, Filecoin uses the VRF functions, so verifiable random functions, which take in a particular seed. And I'm only going to talk more about the seed because having a good quality seed for the VRF is what determines, how relevant, how strong my randomness or my efficacy of my leader election actually is. So with that in mind, the source of the seed is sourced from the DRAN randomness. So the DRAN random signatures are the source for the seed for Filecoin. And the reason here is that we obviously want to have certain properties that we exhibit, such as the secrecy, the identity of the leader that is to be elected on the Filecoin block for creating a new Filecoin block cannot be known ahead of time and cannot be divulged to anybody else. This particular seed should make sure that the process is verifiable. That means the elected leader is able to prove that they have actually won that particular election or the particular round in a fair and verifiable manner. It should be fair, like I mentioned. So, which means that the function, the seed should be able to be used in a VRF, in which they are able to win the creation of a new block proportional to their weight. So, if they have a very low weight, for example, they obviously will not be able to win that particular election or that particular block creations for that particular epoch. And of course, this entire process should be efficient, which means that we don't want to have communications happening between various miners, which means that the source of randomness, the seed that each miner is going to use, it needs to be that VRF needs to be run by miners in their own local environments. We don't want this communication happening across miners, and that's why the distribution aspect of DRAN becomes very important, in which any miner across the world can actually consume the DRAN randomness as the seed for the VRF. So with that in mind, I think we can talk about towards the end. We can talk about how Filecoin actually uses DRAN as the source of randomness. Like I said, the Filecoin chain, blockchain, so to speak, has tip sets, and for each tip set, we actually have random values associated with each of the headers, the Filecoin headers. And each of the randomness values that are in the Filecoin headers are actually sourced and correspond to a 30-second interval epoch, the epoch of DRAN. So when DRAN actually emits that particular final signature, that's actually consumed by Filecoin to create its own in its blocks, and it's then basically mapped to a DRAN round. So each epoch in Filecoin is mapped to a DRAN round. And then these particular DRAN randomness values are used to for the VRF function that I mentioned about for leader election and proof of stake that I mentioned. It's very similar to proof of stake, but here the stake is actually a storage power. So what this means is, as with any proof of stake blockchain, the random seed when it's actually used, the miner can actually check if they're actually able to create the block, and if they're able to place the randomness inside the block, which means that when the output of the VRF function should be, I need to be able to check that the power, my power as a fraction of the total power is actually less than the value that was predetermined and is publicly known on the Filecoin network. So with this process, miners all around the world are free to run their own verification processes, right, and be able to mine blocks. And like I said, these requests.
Sorry, Sid. I don't mean to cut you off, but we are going to have to wrap up this session. Oh, great. It was thank you was the next slide. Awesome. So thank you so much for telling us all about that. Also, your logo is awesome. Whoever created that did a great job. Up next, we have Pooja Shah, the head of product at Protocol Labs. She has a presentation about the features of Filecoin that allow for large data sets. And she's going to tell us how organizations are already using and realizing the benefits of these features. So Pooja, you're up next.
Hey everyone, as Bailey mentioned, my name is Pooja and I'm the head of product at Protocol Labs. Super excited to be here today on the 1-year anniversary of Filecoin mainnet launch. It's amazing. So much has happened. I can't actually believe it's only been a year, but really, really excited to celebrate this incredibly important milestone with our amazing community. So today I'm going to talk about large data on Filecoin. And as Bailey mentioned, I'm going to just start by taking a step back and looking at what has really happened in the Filecoin network over the last year from a couple of different perspectives. So looking at some of the network growth. Then I'll talk about why Filecoin is a really great fit for large data sets, and then touch on some case studies of organizations that we've been working with to get their extremely important data sets onto Filecoin and some of the unique benefits that they've seen as they have been embarking on that journey. So first, taking a look at Filecoin by the numbers over the last year. So one thing that continues to impress me every single day is that Filecoin's reach really truly is global. That we have more than 3,400 participants on the network that are storage providers that span locations across 45 countries across the world and hundreds of cities. And together, these more than 3,400 storage providers represent more than 15 exabytes of storage capacity, which is a truly mind-boggling number. I went back and looked at some of the talks that folks had given around Filecoin launch, and we were talking about how some of the very large cloud providers in the world are like getting to exabyte scale. And already the Filecoin network in just 1 year of existence has become truly one of the largest storage networks on the planet, which is so exciting and incredible. And this network is growing at a rate of 43 petabytes every single day. The other really interesting thing about Filecoin is that the market is hyper competitive when it comes to storage prices. The average cost of storage on the Filecoin network over the last 30 days looks like to pay for 1 terabyte of storage for 1 year on Filecoin costs less than $1. And if you compare this to maybe the nearest traditional competitors, maybe something like Amazon Glacier, which is more than 20 times the cost of storage on the Filecoin network. So really, really incredible to see the storage network itself and how it's grown. We also have a really incredible and expansive developer ecosystem. There are more than 7,500 contributors who are developers that are actively contributing to many different projects within the Filecoin ecosystem. There are more than 400 applications that have been built on the Filecoin stack, more than 100 venture-funded startups, and through some of the products that we've been building specifically for application developers, there are now literally more than 10,000 application developers that are building really inspiring new use cases and applications also on top of Filecoin using products like Web3.storage, NFT.storage, Estuary, and so on. And you can see here some of the logos of some of the partners that we work with, mostly within the Web3 space, but also some other institutions as well. And then, of course, one of the core reasons that Filecoin exists is to store humanity's most important data. And it's been really incredible to see, this is an area in which we really have seen so much growth that has been very inspiring for our team over the last year, because this is just so core to why we do what we do. But more than 600 organizations have been storing their data on Filecoin. And together, these organizations represent more than 200 petabytes of data that have either already actively been stored on the Filecoin network or are in planning phases for storage over the next several months. One other area that we recently started investing in as well, I'd say over like the last year or so, is in the NFT space. And over the last couple of months, we've seen more than 7 million NFTs that have been stored on the Filecoin network. So Filecoin, I mean, hopefully it's just a brief whirlwind through some of the numbers of what's happening on Filecoin, and hopefully that gives you a sense for the scale and just potential that this network really has. So I wanted to spend a little bit of time talking about so what are some of the unique features and capabilities that make Filecoin a really good fit for large data in particular. So, as we all know, obviously cloud storage today is a critical part of our internet infrastructure. But we at Filecoin believe that there are some fundamental challenges with this infrastructure, that especially when we talk about storing humanity's most valuable data for decades and centuries, these challenges become really concerning. And we think that there are alternative solutions that can do a lot better. So what are some of these challenges? The first is that cloud storage is centralized. There are a handful of companies that many of us could recite, that's this very short list of who those companies are, that control the vast majority of the cloud storage market. And because of this oligopolistic nature of the cloud storage market, a lot of these providers are able to make decisions and policy decisions that are maybe in the best interest for their businesses, but maybe don't give the flexibility and control to their users that they would actually desire. One particular example of this is that maybe as a cloud service, you're choosing to build and maintain data centers in locations where you're seeing the most activity, but that maybe isn't the best in terms of providing good service globally. But because all of these decisions are centralized in one individual company that has its own set of priorities, this may not be in the best interest of users, but it is the decision that gets made regardless. And so it can be really constraining for users. In addition, because most of these cloud storage companies have proprietary interfaces, it makes it really difficult for users to go and solve their own problems with protocol level innovation. So we think the centralization of this extremely critical infrastructure is a challenge. But in addition, we've also seen that cloud storage can be very brittle and very fragile. I think many of us have probably seen examples over the past several years where network instability can lead to data accessibility issues, where you as a user maybe have stored something on maybe unknowingly through an application that uses a particular cloud storage provider, and network level issues make your data now completely inaccessible. And these networks don't tend to have the level of self-healing and redundancy and resiliency that we think truly decentralized storage networks can have. So it's one element of fragility that we see in this type of infrastructure. And in addition, the cost of moving an organization's data to one of the cloud storage providers is also risky, because it's so difficult to get the data back out that you're really concentrating your risk with whichever provider you've chosen. And you don't get to have, again, this sort of like de-risking of having multiple different providers that you as an organization are working with. And so that concentration of risk is something that we think is also very brittle. And then the last challenge here that we see is, we all probably know intuitively, and maybe some of us have seen the statistics about just the insane growth of data that is being generated every single day in our world. We are becoming so digital first, and it's just, projected to be several zettabytes of data that will be created over the next several years in our society. As we go more and more down this path, our digital and cloud and storage infrastructure cannot continue to be so expensive. And a lot of folks think that, storage is a commodity, it's very cheap. But when we get to the sorts of scales that we talk about with very large data sets, this actually isn't true. And especially when we talk about data egress or retrieving data once it has been stored, that is especially not the case. We've actually spoken to a number of organizations that find the data egress costs from cloud storage so high that sometimes they just choose to abandon the data and just convert it from tape again or whatever, because they can't afford to pay the cost of data egress off of this infrastructure. So we think these are some of the challenges that are problematic as we want to build like centuries and millennia grade robust infrastructure for humanity's most valuable data. And this is what Filecoin sets out to do. It's to create a decentralized, efficient, and robust platform for humanity's data. Some of the ways that we do this are, focusing in on the decentralized part, because Filecoin is this network of 3,400 plus storage providers, as I mentioned. There isn't the same notion of a single point of failure. You as an organization can choose to work with just one storage provider. You could choose to work with 10. You could choose to work with all 3,400 or more and growing. And that is an option that clients have on this network. The other thing as well, just given the way that Filecoin is built as this open source first, very open network, you as a user can, if there's any particular feature you want or anything that you think is really important that this network has, the fact that Filecoin is open source enables users to solve their own problems or to work with organizations to do this protocol level innovation and to solve these problems for themselves and also for other users on the network too. And the fact that it's open source enables that. Filecoin also is very robust. There are a number of mechanisms that have been really thoughtfully designed over several years to ensure that as an organization, if you're storing your data on Filecoin, you should have extremely high certainty and confidence that your data is going to be stored for the long term. We've innovated on a number of cryptographic mechanisms, different proofs. We have an extremely robust crypto economic model that had a truly inspiring amount of research and simulation and verification that went into it and has proven to hold up over the last, at least the last year, and is projected to do very well for the foreseeable future. So, there are a number of really, really thoughtful mechanisms that go into making sure that your data is properly stored and is going to be available and online whenever you need it. And then the last thing that's really compelling about the way that Filecoin designed is that it is a marketplace. And as we've seen in marketplaces in other industries, marketplaces enable efficiency in a number of different vectors. Of course, with pricing, which is why we've seen the price of storage on Filecoin so low, more than 20x cheaper than the nearest alternative. But also it enables a lot more granularity and flexibility in terms of what you as an organization can choose as a potential storage solution. You don't get this just black box, standard solution that everyone else gets. If you want to customize for your particular use case, you have that ability, and the efficiency and liquidity of storage types in the Filecoin market enables a lot more flexibility for users. All right. So those are some of the reasons why Filecoin, I think, is an extremely compelling solution for large data sets. And so I wanted to give some examples of how we've been working with organizations and why Filecoin has been really, really great for their particular use cases. So the first case study that I wanted to talk about was our work with the USC Shoah Foundation and Starling Lab. If you haven't already heard from Jonathan Doughton, who's the founding director of the Starling Lab, I'm sure he's giving one or many talks at Orbit. This is a really incredible use case, and he's a great speaker and is such a great storyteller. So I would highly recommend you go check out those talks. But the USC Shoah Foundation is a nonprofit organization that manages the world's largest archive of testimonies from genocide survivors. And the Starling Lab is an organization that's building a framework in collaboration with the Shoah Foundation and other groups, such as at Stanford. It's a framework for data integrity so that we, again, as we're moving to this increasingly digital first society, we can have really significant trust in our most critical digital records, and we don't have to feel like we're vulnerable to things like misinformation. This particular genocide testimonial archive is called the Visual History Archive, and it represents more than 8 petabytes of data of video testimonies from more than 55,000 genocide survivors around the world. You can see in this slide, it's more than 62 countries. These videos are recorded in more than 44 languages. And we're in process right now to get all of these archives onto the Filecoin network, and that is actively underway. So some of the core benefits that Filecoin has provided for this use case are that it has really leaned into this idea of Filecoin's cryptographic proofs and this being a actually publicly verifiable stamp that the data that is intending to be stored on Filecoin is properly stored and is safely available for the long term, and actually exposing these cryptographic proofs to users so that they themselves can go and verify, yes, is my data still stored on the network? And you can use these proofs to gain that confidence. Filecoin also leans into, just like the IPFS network, leans into content addressing data which is essentially a way of referring to data by a fingerprint of the data itself, as opposed to just an arbitrary name. And this is, best practice in a lot of archival communities because it helps mitigate data tampering. You always know that if you're using the particular content identifier to look for a piece of data, that's what you're going to get, and you're not going to get some other data that had been tampered, some doctored in some way, but was named the same way as the original file, and getting this doctored version back. So the data integrity native features of Filecoin have been really beneficial here. The Filecoin blockchain is also a public record that includes information about who owns the data, what are these content identifiers, when was this data published, where is it stored, which geographies, with which individual storage providers, et cetera. And this, using the blockchain as this like public provenance record, has also been extremely valuable when we talk about this type of archival data set. And the last thing here is that we've seen there be a lot of value in the flexibility and configurability of the Filecoin network, because the Shoah Foundation and Starling Lab have had a lot of specific needs when it comes to which storage providers they feel comfortable working with, how they would like to encrypt their data before sending it, for example, or not, the number of copies they want to store on the network, and which geography should have this data, which should not, et cetera. And so Filecoin enables all of those flexible choices, which has been extremely valuable in this case. And we have a quote here as well from Jonathan about the value of Filecoin for the Shoah Foundation. Another case study that I wanted to talk about is a really different sort of project, but there are two programs in particular. One is called Slingshot, and the other is called Filecoin Discover, both of which were started by Protocol Labs around a year ago. And so Slingshot is a community competition in which we are trying to mobilize, a massive community of folks who really care about preserving important data sets and work with them to collectively onboard this data onto the Filecoin network. And Filecoin Discover, it has a similar objective, but operates differently, where it's more like an open marketplace where storage providers can buy the data sets that they want to store and preserve on Filecoin. So between these two programs, we are storing more than 42 petabytes of data. And this is, already like actively in progress. Like this data has already been stored on Filecoin. It's really been amazing to see this happen. And some of the things that we have learned that Filecoin has been really successful at in this use case with public data sets is that we've seen, the fact that Filecoin is truly global has been a real advantage here, because we can store many, many copies of these data sets all over the world. And as you can see in this sort of Slingshot screenshot here, that some of these data sets are being stored in like more than 10 countries. And when you think about like community owned data and how we've all seen, I'm sure, for certain data sets, like local mirrors that communities will build because they want a copy of that data set closer to them. This is something that the Filecoin network just very naturally enables. And so it's, just makes the data much more highly available, much faster to access, and just much more resilient. If you have 10 copies versus one, much less likely that data is ever going to disappear from the internet. So global redundancy has been a big advantage here. The other interesting thing too is that because we've been working with this truly massive community of hundreds of community members that are working together to preserve these data sets, we've also developed this like massive library of documentation about how to interact with large data sets, store this data on Filecoin, how to get the data back out, and a bunch of tooling as well that has been built in order to make this sort of processing and onboarding of petabyte scale data really easy on Filecoin. So some really interesting use cases here as well that I'd encourage folks to look into. And then more recently, a recent project that we began working with, although we've been friends and partners in a number of different efforts with the Internet Archive for many years. But over the last few months, we've begun the long process, but very exciting process of onboarding all of the Internet Archive onto Filecoin. So if folks don't know, the Internet Archive is this really incredible nonprofit library of millions of free books, movies, software, websites. If folks are familiar with the Wayback Machine, that is the Internet Archive's work. And so in particular right now, what we're working with the Internet Archive on is to archive what's called the end of term web archive data set. And so what the Internet Archive does is basically at the end of every presidential term, they'll go through and crawl all of the government websites in the United States and take a snapshot of all of those websites. And then they do this at the end of every presidential term so that we can maintain this record of how does our government's view on on its mission and what it does change from administration to administration. And so there are more than 60,000 websites that are part of this archive today that are currently in process of being onboarded to Filecoin. And then we're actively planning what does it look like to get the rest of like the 70 petabytes plus of the full internet archive on Filecoin as well. So some of the core advantages for this use case have really been leaning into the decentralized nature of the Filecoin network and just this belief that, when you think about, it's really amazing actually, like what very long-term archivists think about. But when we think about, protecting and preserving data for thousands of years, that really doesn't make sense, honestly, for it to be stored in just a few servers. It really needs to have a very robust infrastructure that has good mechanisms and resiliency and self-healing properties within it, so that this data, in the unforeseen circumstances that will happen over the next 1,000 years, can continue to live. So the decentralized nature of Filecoin and some of these like self-healing elements make Filecoin a very compelling choice for this data. The fact that the way that Filecoin is designed is really intent to persist data for the long term is also very compelling here. And this is a little bit more tactical, but there's so much flexibility in the types of tooling that can be used to bring this data onto Filecoin. It's not this like very strict, very prescriptive pathway for the organization. So they can really choose bits and pieces of tooling that are going to make this a very easy on-ramp for them. And so that's one of the things that has made this also a much easier onboarding process than maybe it would have been otherwise. And then the last one I'll just really quickly touch on is a recent partnership that we have been working on with the Columbia University and Max Planck Institute. And they're building a new data sharing solution for climate data sets. So the use case here is that a number of researchers across different organizations generate data. They'd like to all contribute this data to a sort of like shared pool so that they can then do analyses on the data that they generated, but also on data that's coming from other researchers. And so it's sort of this like use case of research collaboration. And the plan here is to onboard more than 1.5 petabytes of climate data sets, so that more than 40 research institutions can participate in sort of this like shared pool and research collaboration project. So some of the advantages of Filecoin here have been that this notion of like there really is just natively this unified access layer. Once the data is on the Filecoin network, any researcher from any organization should be able to access this data via the same layer. There's no special permissioning or anything that's required. The open nature of Filecoin enables this. And so that's one thing that's been compelling here. The fact that Filecoin is hyper competitive, and actually in this case, I know I mentioned average costs are something like less than $1 per terabyte per year, but so far all of the data in this case has actually been stored at zero cost. And so most of the costs here have been in data processing and transfer, which is the case for any sort of data migration and onboarding project. And so the fact that Filecoin, especially for research institutions that are not like corporations that can afford to spend hundreds of millions of dollars in storage, this is like a really compelling feature. And then, of course, the fact that Filecoin and IPFS natively interoperate has also been compelling here, because we want to be able to leverage the extremely broad IPFS network to as a distribution layer for this scientific data. So, we've as Filecoin has been evolving over the last year, we've started to get some more nods and sort of like just reports on the fact that Filecoin actually really is a solution that is appropriate for high SLA data services for large data sets. And so there's some quotes here from some of our friends at GigaOM. But it really, the main thing I want to impress is that these are just a few examples, but Filecoin has really been built to store large data sets, and we've seen some initial examples of this, and just can't wait for more organizations to come forth and say that, hey, we think this is the right way to think about long-term storage of our most valuable data. And we want to explore what this looks like. So we think Filecoin can support so many use cases, and are really excited that we've had some initial successes here that can start to be the foundation for more use cases down the road. So yes, I wanted to say, get in touch. Thank you so much for listening to this presentation. If you want to talk to us about storing your large data, please reach out on email or Slack. We'd love to talk to you and see how we can support your organization. Thank you so much.
Awesome. Yeah, thank you so much, Pooja. It was really interesting to hear about those use cases. It just makes Filecoin and all this crypto world a little bit more real. So awesome to have that talk. closing out our exit velocity track on the core protocol innovations and updates that make Filecoin so useful for the decentralized web. We've got a session on GPUs on Filecoin by Volker Misch, a research engineer at Protocol Labs. This is a pre-recorded session, so go ahead and hit play.
Welcome everyone to my talk, Filecoin and GPUs. So the goal of this talk is that you get an idea about how the process of creating a proof of replication is, and that you get a good understanding of which parts work great on the GPU and which are not, which should be done on the CPU, and especially for the parts for the GPU that you roughly know how they work. But before I get into the details, as this is an event celebrating Filecoin for 1 year, I also like to show you the progress. So I've run the proof of replication on some hardware, and so the same hardware from a version a year ago and the version that we have today. And as you can see, the version a year ago for sealing a 32 gigabyte sector took about 3 hours. And now we are down to about 2.5 hours, which is a great improvement. All the details about this graph will come later again. So this is just to get you excited. So if I talk about Filecoin, I mean proofs in this talk, because Filecoin means many different things to different people. So sometimes people refer it to as the protocol or as the cryptocurrency, or sometimes as the implementation like Lotus. But in this talk, I mean the proofs as in proof of replication and proof of space-time. As this talk is about GPUs, I also quickly like to talk about what GPUs are good for. So if you have huge amounts of data and you have some operation that you can apply to the data in parallel and crunch through it basically in one step, that's good for GPUs. What they are not good at is if you have some interdependencies. And then we will probably just get back to the CPU. And Filecoin actually has both those things. So we have things that are intentionally not parallelizable, so they run on the CPU, and we have parts that we want to move out to the GPU in order to improve the performance. So this talk concentrates on the POREP, the proof of replication. Sadly, I don't have the time to talk about the proof of space-time. So the proof of replication is also known as sealing and has 4 phases. 2 big ones. So we make the difference between the pre-commit, which I would call the preparations, and then there's the commit, which is about the actual proofs. And as you can see, those phases again split into pieces. And the important thing here is now that we have kind of like a CPU heavy phase and we have a GPU heavy phase. But now I will get into the detail through all those 4 phases. So let's start with the pre-commit phase 1. This is about SDR. SDR stands for Stack Depth Robust, and it's about encoding. So what we do here is we take the original data and encode it in a unique way. And here the important bit is the unique, because if you do the process again on the same data, you will get another replica copy that is again unique. And this is part of the whole process because we want that people store unique copies of the data. And this step is not parallelizable by design. So it runs on the CPU and it takes quite a little bit of time. What it does in the background is mostly it's reading a lot of data from disk, then it's doing some SHA hashing and writing those hashes again. But the point why it's not parallelizable is that the hashing, you often depend on previous hashes to hash the new hashes. So therefore, you have those interdependencies. And in this step, there's also some basic tree building, which isn't really performance critical, but tree building is kind of core to the proof of replication. Therefore, I want to briefly talk about what Merkle tree building means. So what is a Merkle tree? Here you can see an example. So at the bottom, you have your data you want to build your Merkle tree on. And what you do is you have a certain number of children. In this case, it's 2 children. So we call this the arity of the tree. In Filecoin, we also have trees which have, for example, 8 children. But in this case, it's only 2 children. And so you take 2 pieces and hash them together. And then you have a parent node. And you do this with all your data, and you have then several parent nodes. And then you again hash those parent nodes to get new parent nodes. And in the end, you have the root node with 2 children, which is basically the hash of all your data. So why is this interesting, or like why would you do this? There's something called Merkle inclusion proof. And what you can do with this is, if you want to prove that certain bytes are part of your data, you would normally transmit the full file and look into the file. But this is not really efficient. So what you want to do instead is that you only transmit a proof, a Merkle proof. And here you can see in the light gray boxes that this is what you would need to transmit. It's only a subset of the tree. And what it actually is the parents of the F in this example and the siblings. And with all this information, you can then verify that F is really part of the data. Let's get to the next phase. It's the pre-commit phase 2. It's about Poseidon hashing. So again, we do some Merkle tree creation. This time, several ones. I won't go into the details, but the important bits is we use Poseidon hashing for this. Poseidon hashing is a hash algorithm that works on finite field elements. What they are, well, they are a cryptographic primitive. That's all you need to know for now. I will get back to this later. And those this cryptographic primitive is used in snarks, which I also get to back later. And they are just better than or more efficient than working with SHA hashes. And there, the tree building is highly parallelizable. So therefore, we do it on the GPU. So I will get to the exact steps. So first of all, for the Poseidon hashing, you need to initialize it with some constants. This is just done once. If you start the proof system, it's done once. So you just do it on the CPU. Then something happens in kind of a loop. So if you think about the previous example with the Merkle tree. So you see at the bottom, you have lots of data. And you then take, let's say it's really huge amount of data, which is bigger than the memory of your GPU. So let's say you take 1/3 of the data and you batch it up, and then you put it on your GPU. And on the GPU, it can then do this parent calculation of all the elements in parallel. So it's very good for GPUs. And once we have those parents, what you're then going to do is that you then return them and you create the next batch into the calculation. So it means that in this step, we do the actual tree building, and the tree logic and the batching is all done on the CPU. And only the actual hashing is done on the GPU. So only a small part. Let's get to the next stage, the commit phase 1. This is about Merkle inclusion proofs. So
we create those in order to make sure that this replica data that we created contains the same data as the original input. And this is a really fast process. So on a beefy machine, it takes less than a second. So therefore, we just do it on the CPU. There's no point of putting something on the GPU if it's that fast. And finally, we have the commit phase 2, which is about snarks. And first, I would like to talk about like why do we need another phase, because we have already like proofs to prove that the replica is the same as the original data. The reason is that those Merkle proofs are quite large, and it wouldn't be feasible to putting them on chain. So what we do instead is we use snarks in order to make those proofs smaller so we can put them on chain. And now you probably want to like, what are snarks? Like, what is this? So that's probably, I could talk for hours and hours trying to explain what they are. I think, to me, snarks is this magic cryptographic black box that does some magic things and contains lots of cryptographic primitives. I will go into some bits of it, but not all details. This would then be a separate talk. So what you do is you build something called a circuit. That's kind of, I mean, it's still software, but I would say it's basically the physical representation of a system that does some magic things. And those are basically polynomials, as you know them from school or university. And you have lots and lots of them, really a lot. And all those operations that you do in those snarks happen in finite fields. So you need finite field arithmetics because it's also working on elliptic curves and so on. So now we get back what I earlier said is about the Poseidon hashing. So Poseidon hashing is native to finite fields. So therefore, it's a good fit for those snarks. So what's now actually running on the GPU? So what we want to do is, if in the system, we want to evaluate those polynomials at random points, which means basically we want to get out the results. So you would have, as you can see at the bottom, like such a formula, and you can do it with pen and paper, and you just want to put in some value for the x, and you have some values for the a's, and then you do a calculation and get some result back. This is what evaluation means. And we want to do this efficiently on the GPU. So first, what we do is something called inverse fast Fourier transform. And what it does is, so the problem is that in the circuit, those polynomials are represented in a certain way, but to do the actual calculation, we need to represent them in a different way. We actually need to transform them into a coefficient representation, which is the one that you can see at the bottom, and most people are used to or think about when they talk about polynomials. So we do this transformation first, and this is again an operation that is parallelizable because you do some divide and conquer algorithm, and you then recursively step through those things, and in the end you get the coefficients back, which is those a's in the polynomials. And the other thing is then, if you actually want to evaluate this polynomial, you use a function called multi-exp. So what it does is that it now can operate on many of those elements at the same time. So here is, I've put the kind of like the function call. So you put in the coefficients and you put in the x. So the x, so those things are then really like concrete values and not variables anymore. And then you kind of do this calculation in one big step on the GPU and you get the result back. So to recap, the parts that run on the GPU is from the whole process of creating the replica and sealing and creating the proofs. It's actually only the Poseidon hashing, the fast Fourier transform, and the multi-X. So let's look into what it means and what performance improvement it gives you. So this is again run on the same machine as from the first slide. And now you hopefully have a better understanding of what those bars mean. So let's look into detail. So at the top, we have the CPU runtime of a proof of replication of a 32 gigabyte sector. And in the bottom, we have if we have the GPUs enabled. On this machine, we even had 2 GPUs. So what you can see is the pre-commit phase 1, which I named SDR encoding, is the same on both. As I mentioned, it runs on the CPU. It doesn't use a GPU at all. So therefore, it totally makes sense that this runtime is the same. And it takes a lot of time. It's about 2 hours. The next phase is the pre-commit 2, which is about Poseidon hashing. And there we use the GPU, as you remember. And we can clearly see here, like on the CPU, it takes something like, let's see, like almost an hour, like 45 minutes. But if you use the power of GPUs, it's a matter of 10, 12 minutes. And the next phase, the commit 1, which is the Merkle inclusion proofs, you can't actually see it on this diagram. As I mentioned, it takes basically less than a second. So therefore, you can't see it in this diagram. And it's for both. It's just both cases. It's just this fast. And then finally, we have the commit phase 2, which is the snark magic. And again, we can see that if you run it only on the CPU, it would take over an hour. And then it's a matter of 15 minutes or so. So you can see it really improves the performance a lot if we use the power of GPUs. And now, finally, I'd like to talk about what we use underneath. So the proving system I was talking about is programmed in a programming language called Rust. And of course, we use libraries for certain things. And I'd like to get into some of them, the important ones. So we interact with OpenCL, and there is a library called OpenCL3, which is well maintained, and it actually replaces a library that is no longer maintained called OCL. So we've used OCL in the past, but with newer versions of the proofs, we use OpenCL3. And as you've probably seen, the transition was quite seamless. Probably you haven't had any problems with it. And what I'm especially proud of is that Protocol Labs helped in the early stages of getting OpenCL3 polished, because it was still quite young, but we've bet on it, and it was a good decision to spend some time on it and improving it and make it work for our use case and also make it work for other people. So now it's really like a general purpose library and not only for Filecoin. It can be used by anyone. And it's also its intention. On the CUDA side, it doesn't look that happy. The Raster CUDA library is only partially maintained. And currently we even need to use a fork of it, but it should be short-lived. It's just a single function, and I hope to get it upstream because I really don't want to maintain a fork of it. Then we also, of course, with the most recent version of Lotus in the proof system, what you can do is you can switch between OpenCL and CUDA. And so we have code for OpenCL and CUDA. And of course, you don't want to code everything twice. So we've built an abstraction library to make this easier for you. This is, again, not Filecoin specific, but general purpose. So if you have those needs, have a look. And finally, there's a library called EasyGPU, which is for finite field arithmetic over prime fields and elliptic curve arithmetic. And what this is about is it's highly optimized code for GPUs. And we want to make it again like also usable for other people outside of Filecoin. And currently it doesn't contain FFT and MultiX that I've presented, but the plan is to move from some other library to move it into that library so that people that need those functions can just use this library and don't depend on many other libraries or Filecoin specific stuff. All right, that's all I have for today. Thanks everyone for your attention.
And we're back. Thanks for sticking with us today. I hope that you learned a lot about what makes Filecoin tick and why it's so integral to the decentralized web. For me personally, as a journalist that uses her clips and my published articles and videos online as a resume of sorts, I've recently gotten firsthand experience about why decentralized storage is so important, because a recent redesign of a publication I used to work for somehow disappeared a good amount of my content. And so that really affected me, and that kind of sucks for me because I don't know if I will be able to get that back. And so it's become really clear why Filecoin and IPFS and those decentralized storage products are necessary. So in this next session, we have Zuko Wilcox of Zcash. He probably goes without much of an introduction, but the original cypherpunk and the founder and CEO of the Electric Coin Company. And alongside him in this keynote session is Marta Belcher, chair of the Filecoin Foundation, the general counsel for Protocol Labs, and special counsel for the Electric Frontier Foundation. So you two, welcome to the stage.
Thank you. Hi, thank you so much for the introduction. I am so excited to be here with Zuko and with Bailey. Of course, as Bailey said, Zuko really goes without needing an introduction as one of the founders of Zcash and the CEO of the Electric Coin Company, which is one of the companies that supports Zcash today. And I'm so excited to be back on stage with Zuko. Last month, we were actually on stage together at Mainnet to announce a partnership between the Filecoin Foundation, Protocol Labs, ECC, and the Ethereum Foundation. And so Zuko, do you want to talk a little bit about that partnership?
Yeah, the partnership we just launched with those organizations is about extending the Halo zero-knowledge proof system that my core team at the Electric Coin Company has come up with, and researching how to use that new technology in all of those networks.
So do you want to talk a little bit about sort of, a lot of this partnership has to do with unlocking recursion in Halo, which, do you want to talk a little bit about sort of explain what recursion is and why it's important?
Yeah, thanks. Okay, so Halo is a new zero-knowledge proof system, and it's about to be deployed in Zcash as the first live deployment of it in January. And that's improving the security and privacy in Zcash. But there's another aspect to Halo that's not yet been explored, which is the scalability benefits, and recursion, like you ask, is the key to that. So let me try to explain briefly what recursion in a zero-knowledge proof system is. A zero-knowledge proof system is a way to, which many of you might already know because it's so important to Filecoin already. A zero-knowledge proof system is a way to prove like a set of facts without revealing any of the information in there, just to prove the truth of the overall package of facts. And that means there's some deep connection, actually, I think mathematically, between scalability and privacy, because in computer science, scalability is really about not transmitting or computing on unnecessary information, right? And privacy, in a sense, is about not leaking or disclosing or transmitting unnecessary information or information that you don't want to share. So there's some interesting mathematical connection. Now, recursion, so Halo was the first zero-knowledge proof system that was trustless, meaning there's nobody who's responsible for setting it up, and you have to rely on those people not to cheat or anything like that. It's just pure math with no special parties involved.
So it's trustless. Halo was the first zero knowledge proof system, which is both trustless and capable of recursion. Now, recursion is this mind-bending concept, which is the system is powerful enough that I can give you a proof that some other proofs are all true. And that means you can kind of stack that, right? I can give you a proof that these other proofs are all true. Now you can give someone else a proof that my proof is true, plus other things are also true. And that is potentially a really powerful building block for scalability, because now there's no limit to the size of the data set that you can prove facts about with a one efficient proof. Does that make sense?
It totally makes sense. It definitely makes sense. And I think for me, just speaking for the Filecoin Foundation, I think I'm so excited about this partnership because we really think that first of all, we think unlocking recursion in Halo for the reasons you've talked about is very, very cool. And also, we're really excited to explore how Halo might be used in the Filecoin and Ethereum ecosystems to really improve the scalability and efficiency the way you're talking about. And we really think that cross-chain proof verification could really unlock a lot of possibilities for all three of these networks. So for example, that could include, right. So that, for example, that could include, expanded uses for Zcash. And we're just very, very excited about this collaboration. What about you, Zuko? Like, what's the most exciting thing for you about this partnership?
Yeah, well, both the immediate thing that we've already started doing together, which is implementing the recursion. And like I said, Halo itself is already in the process of getting deployed to Zcash mainnet. It's scheduled to go live on Zcash mainnet in January 2022. But that's not the recursive part. That's only for just strengthening the core. But then probably the next live deployment of Halo, I'm hoping, is going to be in Filecoin to use the recursion to improve Filecoin scalability. And all networks, Zcash, Ethereum, Filecoin, and pretty much all blockchains have a scalability problem that they're facing. And so I'm excited about the possibility of that making, like, the purpose of Web3 in general and Filecoin, Ethereum, and Zcash is to make a more democratic world where, like, a world based on consent, and everyone can opt in or opt out or choose how they want to use it, and it does what they want for their purposes, not serving some like corporate monopoly or something. And for that to work, we really need scalability, because we need to be able to provide it to lots and lots of people at low cost. And that's what scalability is for. And then I'm also, let me keep going on things I'm excited about. I'm also really excited about something else you mentioned, which is sort of the yet to be discovered applications of this technology. Like you mentioned cross-chain interop, and that's really interesting, because if you have the ability, if you have recursive proofs, now you have the ability to prove arbitrarily complicated data structures. That includes, you can prove the entire history and state of an entire blockchain in a single proof. And we've already demonstrated that. And that implies maybe, and this is where we get into what's fun for me as a technologist, is exploring new things and trying new things and finding out if they work and how, what the results are. So maybe with that, we can do what you were saying about use this fundamental technology as a way for other blockchains to sort of assess the state and the correctness of the state of other blockchains. Because I can give you a proof that says, here's a proof of the entire history of the Zcash blockchain in one little data chunk, and now the Ethereum and Filecoin blockchains can process that, and vice versa. That's exciting, and there might be other applications too.
I'm excited about all of those things, and especially, as you said, the potential applications in the future, and particularly the cross-chain potential applications. And I think also, just for me personally, one of my other roles is I serve as special counsel at the Electronic Frontier Foundation, and I do a lot of thinking about, privacy and civil liberties. And so another thing that really excites me personally about this partnership is really the possibilities surrounding privacy. And obviously, you're sort of like a central figure in thinking about privacy and cryptocurrency. Well, thank you. But I would love to just hear from you sort of how you how you think about privacy, and how you think about that topic.
Oh yeah. I think about it, I think a little differently than most people do. A lot of people think of privacy as like secrecy, like having high OPSEC and I don't know, locking your doors with better locks or, higher, more security or more secrecy or being more closed about what you share or anything like that. And I don't think about that. That's not what privacy means to me at all. To me, privacy is just about consent. It's like if like you choose who in your life you want to share stuff with, like you're having a baby or you're sick or anything in your life, it's up to you who you share with. Anybody else making that decision for you, that's just wrong, right? But if you choose to share things either with a lot of your friends or if you choose to post things in public, to me that's actually the same thing. That's your consent. That's something that Web3 needs to enable everyone to do, to share and to share selectively on their own terms. So privacy to me is just about consent, and it's just inextricable. Like all of Web3 is about privacy because it's about empowering the individual to have their own agency honored by the tools that serve them.
I love that. That's such an interesting perspective on it, and that's just a great way of thinking about it. And just for me personally, really, I think I've been really concerned over the last year with just increasingly seeing how regulators are thinking about privacy and anonymity. I think there's this sort of misconception among regulators that anonymity or privacy are bad or illegal. And this is something we've seen regulators, for example, create a term for this. They have a term, anonymity enhanced cryptocurrencies, the AECs. It even has an acronym, right?
Yeah.
And so it's like the regulators.
We need a new acronym.
We need a new acronym, AECs, anonymity enhanced cryptocurrencies, so that we can throw that in. So like, for example, the DOJ, the Department of Justice, had a crypto enforcement framework where they talked about these anonymity enhanced cryptocurrencies. And, I've been really concerned about how they have been talking about it. And, for me, I think the most important thing about cryptocurrencies are that they can import the civil liberties benefits of cash into the online world. I think it's important for people to understand that privacy and anonymity aren't bad or illegal. They're absolutely essential for civil liberties. And that's especially true for financial transactions. It's not an exception. It's especially true for financial transactions, right?
Yeah.
And I remember, I always talk about pictures that I saw from the Hong Kong protests, which really sort of hit me and really drove this point home for me, which was there were these pictures where there were these long lines at the subway stations where the pro-democracy protesters were waiting to purchase tickets with cash so that their electronic purchases wouldn't be placing them at the scene of the protest. And so for me, that really underscores that, cashless society is a surveillance society, and the absolute importance of, anonymous transactions for civil liberties. So,
I saw those pictures. Me too. I want to push back on something you said in a way. You said regulators have been like targeting Zcash and so-called anonymity enhancing cryptocurrencies. And that's true, but I noticed something really interesting over the last year. It was Trump's DOJ that wrote that paper that you described. And I think I'm seeing something going on right now that I saw in the late 1990s with the launch of the World Wide Web and the 2000s, like about 10 years along in there, which is that some regulators have a lot of different mandates, right? So the law enforcement and national security regulators, both over the last year in their papers and acronyms, or the last 2 years, and also in the late 1990s, they had this opposition to encryption, right? And they, meaning the FBI and the NSA mostly, opposed the deployment of encryption for the World Wide Web at first. And they were successful at blocking it with a lot of dirty tricks and different kinds of campaigning and politics. It was all very interesting. I was involved as a foot soldier. I like sat at my terminal writing code is my contribution. But then it's interesting what happened back then, because I think I see the same thing happening today. What happened back in through the deployment of the World Wide Web is there was this policy battle, like, are we going dark? Can criminals exploit this new web thing? And then what happened was Web 1.0 happened, and people started using the World Wide Web for commerce and for chatting with their grandchildren and normal stuff. It started to become important for people's lives and important for our economy. And once that happened, I think that's what turned the tide, and the national security and law enforcement sort of mandates within government gave way to other mandates within government, like consumer protection and national competitiveness, and like having a prosperous economy, and like protecting people's grandmas when they're using their computers and all that stuff. And I could be wrong. I hope I'm not wrong. I have been predicting this, and I think I see it happening. And so we'll find out in like 5 years if I was wrong or right when we look back on this video. But what I think I've seen happening is that transition is starting to happen with cryptocurrencies. Like 2 years ago, 3 years ago, 4 years ago, cryptocurrencies were like the World Wide Web was in 1997. These weird geeks use it. Like, government people don't use it. They didn't use the internet in 1997, right? You had to like fax them or whatever. They didn't have email. And then, by like 2001 or whatever, everyone had email, and that changed the whole conversation. And I think I see the same thing happening with cryptocurrencies, because there's a huge regulatory policy debate happening in the United States and elsewhere about cryptocurrencies, but it's no longer primarily about law enforcement. Now there's a whole bunch of talk about consumer protection, national competitiveness, international, like the globalization or localization of the world, financial stability, and having an economy with like jobs and savings and protection for all the citizens. Anyway, so you're right that some regulators have spoken. They haven't done anything, but they've spoken about encryption as being dangerous. But that's not most of the regulators, actually. And so I think the tide has shifted. We'll see. What was I going to say? Oh, so in fact, we've already seen how Zcash is like accepted or approved or regulated by a lot of the regulators. That's why it's listed on Gemini and Coinbase and the other highly regulated companies in the United States. And you said something else I wanted to respond to, but I forgot, lost my train of thought.
Maybe you'll remember.
But I know what it was. It was very
good.
simple. You said like civil liberties are important, and I totally agree with you. And I just wanted to point out that's the way we do things in America, right? Like, civil liberties are not the principle of the Chinese Communist Party. So they're being very consistent in the way they're treating technology and everything else they do. But the American way is that civil liberties are an important part of like the safety and the prosperity of our whole society. And I really agree with you that civil liberties are fundamental. And it's also, like we said earlier, that's like what Web3 is about.
Yeah, absolutely. Absolutely. And so I guess, just to sort of, first of all, I hope you're right. That's a really interesting perspective. I think it's a really, really interesting perspective. And I guess that sort of leads into a really big picture question that I really had wished we got to dive into a little more at Mainnet. So since we have a few minutes left, I would just love to hear about your vision for the future of Web3. You've touched on it a little, but I really want to hear about really your vision.
Well, I guess I don't have a very clear vision of the future. I think it will be very surprising to me and everyone else. And that's actually one of the things I love about Web3 is that it respects users' agency more, so that the little nudges and the structure of it is designed to support what its user wants instead of to fit its user into some monopolies like profit model. But that means I think it's going to be that much bigger than Web 2. I think that having four however many companies controlling everything actually really limits how much value people get and how much they use it, how much money it makes, how many jobs it makes. So I think Web3 is going to be a lot bigger, and I think it's going to be a lot more diverse. I think humans are infinitely unique, right? Every human is unique, and I think Web3 is going to provide a satisfying like world for each person that integrates all of their loved ones and their community and their goals in their own unique way. So anyway, that's really vague. I don't know what that's going to look like, but I feel really confident that it's going to be good. I look forward to seeing that.
Awesome. Yeah, I cannot agree more. And I think the points you're making about really fundamentally the issues with having these central intermediaries and experiencing so much of our lives through just a handful of corporations, and really having no choice but to trust those corporations to keep our data safe and protect our civil liberties and, serve us the content that is, real, original. Like, I think as you're saying, this is all a world in which we have more options is definitely a world that I think we're envisioning as well. So I think I speak for everyone at the foundation, at the Filecoin Foundation, in saying that we are just so thrilled to be working with ECC and the Ethereum Foundation and Protocol Labs in this partnership, and really excited to see what kinds of things we can unlock and the applications that might come about as a result in the future.
Yeah, me too.
All right. Well, thank you so much. It's been so terrific to get to chat with you again. And thanks so much for being here.
Thanks, everyone.
Thank you all so much, Marta, Zuko. Nice to see you again. All right. That is basically it for today. Thanks, everyone, for staying tuned in. We have just one more session, just a nice closeout. I'm going to bring Colin Everin back up to the stage with me. We're going to chit-chat a little bit about the highlights, and I think he's going to share his screen so we can see some of the highlights as well.
Hey everyone, good to see you again. My name is Colin. Most of my friends call me Proto Colin. I figured I'd do a quick recap of what day 4 looked like today. And so I'll get right into it with a couple of highlights, and we'll preview some of the exciting things that are coming to the forefront tomorrow morning. So, zooming out, I was trying to piece together a succinct summary of how to capture the last year. I failed miserably, of course, because there were so many things that went on in the Filecoin network that it's hard to put on one slide. But some of my favorite things that I'll highlight that the Filecoin community had built in the last 12 months. First is one of the largest data storage networks on the planet. We've estimated it to be roughly the size of Google Cloud in 2018, which is absolutely remarkable. 2, the community has built the least expensive large-scale network in the world. It is less than 1% of the cost of centralized storage today, if you just take a snapshot at what deals are priced at. The community has built the fastest upgrading blockchain. We more than 10x the available chain bandwidth within 8 months of launch, which is an absolutely incredible feat for the entire community to rally behind. We built an environment where builders can thrive. We've seen over 10,000 developers engage in hackathons so far this year, 250 applications live and are building on Filecoin today, and 500 new teams entering the ecosystem. Filecoin has now become the storage network of Web3. We have over 7 million NFTs stored on Filecoin and integrations with 75% of the largest smart contract blockchains. And what the community has built, which is really special, is incredible breadth of use cases on Filecoin, over 25 categories of use cases. We walked through some of those over the course of today, including NFTs, video, audio, metaverse, biotech, gaming, and many, many more. And so we'll highlight even more of those tomorrow. When you zoom out over the course of the week, Filecoin Orbit has been a massive success so far. Over the last 4 days alone, we've had 35 events, in 12 countries, 5 continents, and 20,000 or more attendees, which is absolutely incredible. And I'm just super excited for this momentum to continue into tomorrow and Saturday. Some of the community events throughout the week have talked about developer tooling, protocol improvements, NFTs, the Green Filecoin Initiative, the decentralized web, policy, DeFi and fintech, the metaverse, Web3 storage, how to store Web2 data sets, the Filecoin retrieval market, and much, much more. And we've had organizers all over the world, including the Filecoin Foundation, IPFS Force, Proto School, Matrix Storage, Web3 Metaverse, FutureX Labs, StoreSwift, and all the others that you see on the screen today. A huge thank you to these organizers. They've been planning for weeks and have just put together an incredible lineup of talks, each of which are very, very different and have very different opinions on how the Filecoin ecosystem will evolve in the future, which is super healthy. Some highlights from the community events this week. I just took a few snapshots here. You'll see some live events in Asia, some virtual events around Europe, a DeFi event around the Filecoin yield curve, a greening Filecoin event, which was one of my favorites, just super inspirational, that Filecoin could eventually become a negative contributor to the carbon footprint, which is incredible. Some more pictures here. There was a recruiting event in Gathertown, a Filecoin Orbit in Lagos, which was incredible, and a few live events all over the world. And then highlights from today, we've had a whole range of speakers, from Juan introducing our 1-year anniversary, to Brewster talking about how the Internet Archive is using Filecoin, to a fireside chat with Sergey from the Chainlink ecosystem, and Molly talking about some of the protocol improvements throughout the week. We had Stephen from IPFS Force talk about the Venus implementation, ZX talk about Hyperdrive and that major upgrade and what it enabled. We had Dirk talk about Market Speed 2, and we had a storage panel of a whole bunch of storage providers, but one of the coolest parts is Dirk, which is a community member in the ecosystem, put together this time lapse of how storage providers have evolved their power and how deals are being made all over the world on this map. So you saw this like amazing kind of time lapse of deals flying back and forth all across the world. On the builders track, we had a session describing some of the major hackathons that took place today. We had 2 of our accelerator partners, Outlier Ventures in Europe and Techstars out in Seattle, talk about the cohorts that they're hosting over the next few months, which was super remarkable. It's great to see some examples of some of those companies that are currently being mentored by Outlier Ventures. And we had a panel with Near, with Hedera and Polygon and other ecosystem partners that have integrated Filecoin as the underlying storage layer of their blockchains, and some of the insights that they had as well. And then we had a long stream of startups. Most of these were kind of launched their products and seed rounds maybe about a year ago. And so it's great to see the updates of some of these startups on what they've accomplished in a year. Mintgate has made a tremendous amount of progress. Secured Finance, which actually started in a hackathon, progressed to an accelerator and raised a seed fund last year, is off to the races in DeFi on Filecoin. Valist and Numbers also had some incredible updates. And so it was awesome to see some of these startups, and there'll be more presenting tomorrow on some of the progress that they've made. Huge preview of tomorrow. We have, I think, 6 different events all around the world that I want to encourage people to go to. We have the Filecoin Orbit main stage, which is the same link that you'll see today. We have a Happy Birthday Filecoin event in Italy, which is really remarkable. Filecoin Amsterdam meetup, which is great. There's a Filecoin Orbit and October IPFS Munich meetup, which I encourage people to attend. And then 2 in Asia, one run by Matrix Storage. It's day 3 of their platform. And then the 5th day of the Wuhan conference for the decentralized web, focusing on IPFS and Filecoin. So check out orbit.filecoin.io for details on all of these events. They're all really, really special, and would encourage you to attend as many as you can. I do want to preview just maybe a specific teaser of a few sessions tomorrow, because I think these are really, really special. We were going to have a community member introduce the Filecoin virtual machine tomorrow, which is incredible news. This is going to open up a whole bunch of possibilities for developers over the coming years. And so I'm just super excited for Raul to present how this is progressing, the timeline for this, and how it's going to come into implementation. Alan Ransel is going to present kind of a summary of the Filecoin Green initiative, so charting a path to a verifiably environmentally beneficial network. If you missed the Filecoin Green meetup, which was 4 hours of incredible content earlier this week, this will be a great summary of that. Jonathan Doughton is going to be talking about advancing human rights with Web3 and featuring some of the amazing work that Starling Lab is doing. And we're going to have a session on consensus scaling and sharding for Filecoin. This is a hugely important technical improvement that could not only help Filecoin, but a number of other blockchains. So I'm super excited to see how this is going to manifest itself and how we can rally the community around some of these technical improvements. So with all that in mind, please join us tomorrow. The website's orbit.filecoin.io. That'll push you to the right places on YouTube and Hopin. Please tweet and tell your friends. We're super excited for day 5 tomorrow, and I can't wait to join you then. Back to you, Bailey.
Yeah, so stick around, Colin. I was just going to chit chat with you for a little bit. I told people that I would put you on the spot in the chat, and so I am going to. There are no questions from the audience specifically for you, but I was going to ask, what is your favorite food?
Oh God, I am a pizza person backwards and forwards. So yeah, I can just demolish like a large pizza if you give me the opportunity.
Great. Okay, perfect. I put him on the spot, everyone. He gave a really great overview of what happened today and also what's coming tomorrow. So like he said, we hope to see you back here tomorrow. And thanks so much for staying tuned. Bye, everyone.
Thanks, Bailey. Thanks, everyone.